Yeah, I think we have started recording. So yeah, I guess most of you were able to copy the files to your own destination. I'll just quickly share my screen, and I'll just show you what happens when you do so. So this is the MATLAB online version. So if you were able to successfully click on the Access MATLAB online from the classroom version, you will end up at this particular link. Otherwise, it will be like only matlab.mathworks.com, the same interface, like no difference. Right. So if you were able to copy this, this IIT Indore exercise files will be here in this list of folders. Okay. And this is the one which you copied using the link, drive link that I showed. Can I see, like, can any of you confirm if these folder is there on your current folder? Hemapriya, can you just look at? Yeah, I can see a few yeses. Yeah, I can see a few. Awesome. Great.
Okay.
Which means
No.
yes, the files are with you.
Okay. For few people, it's there. For few people, it's not there, I think.
Right.
People are able to access it. It's not there.
If you are able to copy it, it will definitely end up here.
Have you copied it? Into
yeah.
Inside the folder.
Sir, is it in the inside the folder?
No, so if you go to MATLAB Drive, there will be a drop down here. If you copy it, then the same files will be copied to the like you can see those files in this MATLAB online version. So what's actually happening is you are copying the files from my personal MATLAB drive to your personal MATLAB drive.
Satish, can you just copy the link and paste it in the chat box once more?
Once more? Yeah.
Because few people have this in the chat box here. Yeah, I have pasted it once more. So if you click on this link, you will end up here. There will be one drop down here, and it will ask you to copy the files to your folder, like copy the folders. And then you'll be able to copy the files to your own MATLAB drive, and your MATLAB online will be able to access those files because it is connected to the drive. Just a second. Are you logging to your Instagram? I'm able to use it. Nothing. Maybe in the websites this one later. If anyone raises hand for something, just let me know. Can do.
Were others able to access the files using the link that I just shared?
Were you able to access it? Okay. How many of you are not able to access it? Participants in the online, can you raise your hand if you are not able to access it?
I think so. Except one or two, everyone can able to access it, I think.
Okay. Yeah, in case you are not like yeah, I think in case you have some problem accessing it, please don't worry. Please follow along. The recording will be there definitely after the end of today's presentation. You can again go back to it in case you are missing out on certain steps. So I guess we can get started now. So
Yes, Pratyush.
yeah, so this is the interface for MATLAB Online. I'll just quickly walk you through what it looks like. So here you have all the folders. Okay, these folders are the ones which are there in your MATLAB drive. So if I go to my personal MATLAB drive, for example, this one maybe. So here you see there are a lot of folders. Okay, and the same folders can be accessed using MATLAB Online. So the same folders are available here. Now in MATLAB Drive, there is a folder called IIT Indore exercise files, which I shared today. And this is the one. Okay, this is the one which I shared. Now, if you notice carefully, I just zoom in slightly more because while sharing the text might look slightly smaller. So for IIT, okay, I'll probably turn off my camera. Just give me some time to save some bandwidth. Yeah. So the folders that we have here, if you notice carefully, some of them are slightly grayed out and they are italicized, whereas some of them have the normal font and they are black in color. So what does that mean? So this basically means that there is a MATLAB path. Will I be able to access the Mathworks GPU? If I use PC installed version of MATLAB, will I be able to use the Mathworks GPU? So you will be able to access, I think, cloud versions of GPU, or if you have a local GPU, I don't think you'll be like there is like the Mathworks GPU or the GPU that are allocated for today's session will be available only through the workshop version. But if you have, instances for Amazon or any cloud services, or if you have a local GPU, you can access them. Good. So as I was mentioning, so all these folders, the grayed out ones are the ones which are kind of inactive at this moment. So if you have the files inside them, you will not be able to run them, or say you have an image file, right? You want to do some image processing operation on it. So if the files are not in the path, then those operations will not be successful. So the first step is to include the folders in the path. So currently the folder that I'm using is already in the path, but say I am taking any random folder, say this one, and I want to include it in the path. So what I'll do is I'll right click here and all these options will come up. Okay, open, preview, rename. You can rename it if you want. And the most important one is add to path. So just go to this add to path option and click on select folders and subfolders. So at your end, maybe this IIT Indore exercise files is not active. So let's say I am removing it from the path for now. So if I am removing it, it will again become italicized and dark gray, right? So if I want to add it to the path, just right click here and click on add to path, selected folders as well as subfolders. So the entire content, see, from italicized it became straight. Okay? The font also shade, the font shade also changed. So now all the files which are there inside this folder are accessible. Were everyone able to follow along? Those who are in the chat, can you please type yes? So just to get an idea. think Rupal mentioned yeah, Subhash mentioned yes. Yeah, I guess most like who are attending from the classroom, I hope you are able to follow them as well. Right, so once that is done, let's quickly get inside this folder. Okay. And there will be two parts. One will be deep learning, one will be IPCV. Deep learning we will cover in the second half. So let's click on IPCV for now. If you click on IPCV, all these files will be available. Like, be able to see all these files. So I will come to what these files are all about in a while. But before that, let me quickly talk about what this interface is like. Now, if you notice, there are three tabs: home, plots, and apps. In the desktop version, you will have more tabs, more options. So under the home under the home tab, you will have, you can click for a new script, you can click for a new live script, and different other options, right? You can also open files. Okay. You can open files which are there in your drive. When you are using MATLAB Online, when you are using MATLAB desktop, you can open files from any folder on the desktop. And there are other options. You can add different specialized libraries. For example, let's say you want to maybe, let's say you have designed some kind of image processing application and you want to deploy it on a hardware. So for that, you might need some hardware support package. And if you click on this add-on section, those hardware support package will be available with you. For example, say maybe Raspberry Pi or say Arduino, something like that. So this is about the home tab. Under plots, there are different options for plots. You can do line plots, stem plots. We will get into that shortly. And there are something called apps as well. Okay, so what are apps? Apps are really easy to use GUI based tools that, like, some of them we design for our users and some of them the users can design for themselves if they are well versed with the MATLAB environment. So these things can be done in here. You can see quite a few apps. For example, say favorites. Favorites are the ones which get used very frequently. There will be something around image processing and computer vision, machine learning and deep learning, math stats optimization, stuff like that. So let's say yeah, am I audible to everyone? I think there was some network issue. Can anyone confirm?
Yes, Pratyush.
Okay, yeah, that's right. So what I was mentioning was there are different kinds of these apps, and you can play around with it. Really. I will actually demonstrate one of these apps in the second half. But here there will be an interface with which you can play around. You can design the options in the interface, and you can also design the backend code or the backend logic, which decides how these components in the interface interact with each other. So these are the three tabs that we have. Here are the folders. Here is the workspace. What is the workspace? Workspace consists of all the variables that we are defining while running the codes. And this is called the editor. In editor, we can just test a few lines of code on the code. Okay. So for example, say I am defining a variable, say A, right? And say I'm saying A is equal to 3 or 4. So if I enter, see this A is equal to 4 is getting saved in the workspace, right? it has a name A, it has a value of 4. This is the size of the variable and this is the class of the variable. It's a double type. Okay. One more interesting thing to note here is I wrote A equal to 4 and it not only assigned the value to the variable, it also printed out the value, right? But what if I don't want to print out the value, right? Because at times, if you are printing out a lot, like a very huge text or something, that will occupy a lot of space in this editor. So let's say I am only assigning but not printing. So in that case, all I'll type is say A is equal to 4, or say change the value to 5 and a semicolon. See, nothing is getting printed out anymore, but the value has been changed to 5. So I am assigning the new value, but not printing it out. Okay. So this is how the editor works. You can just test out simple lines of code using the editor. Whereas if you want to write quite a few lines of code, you can go to maybe the script or the live script. Okay. So in today's workshop, we will be mostly using live scripts. So before that, let me show you what a script is. So if I want to open a new script, I can either click here, new script, or under this drop down new, I can click on script. Okay, see this untitled thing opens. And here you can type a few things. For example, say A is equal to 5. Say I want to find out A square, right? So A is equal to 5. I want to say A square. So in other programming interfaces, you have to type something like say printf or print. But in MATLAB, you don't have to do that. Just don't put a semicolon at that line. It will just print it out. Okay. So if this is what you want, and say you want to type multiple lines, say you are writing B is equal to 6. Say you are writing C is equal to A into A plus B into B. And you want to print it out as well. So no semicolon at the end. Just click on run. And you might have to save the file name. I am saying, well, the file name can be intro IIT Indores. I'm saving the file. And see, the value of C is actually 61, right? 5 squared plus 6 squared, 25 plus 36 is 60. And all of them are getting saved in the workspace. And this particular file intro_IIT_in.m gets saved in this particular folder. So I am currently operating from this IIT Indore exercise files /IPCV folder. This is my working folder. And this .m file, which is only a script, is getting saved inside this folder. Okay. Now, this is fine. A live script is fine. Sorry, a script is fine. But the problem is, when we are doing our curriculum or research work, practice notes along with the codes. For example, let's say you have a notebook kind of a scenario where you are writing down some description, maybe attaching some pics with the description. And then beneath the description, you are writing the code, which tries to execute what has been described above it, right? So those will be really easy to understand, because if you look at the description written above the code, it will be easier for you to understand what the code is trying to do. So for those kind of applications, instead of using a script, we can use a live script. So again, same drill. Either you can click on new live script or go to this new drop down, click on. So if you notice the difference in the file type, this is the .m file. And it's .mlx. if you notice here, this is like a code interface. Right? Now, if I had only written a code, I would have continued with the same thing. A equal to 4, maybe B equal to 5. Then maybe, okay, let me just enlarge this slightly. So if you notice, if you enlarge, double click on this, all the other things get slightly minimized and this window is present. So let's say equal to 4, B equal to 5, and I do the same thing, A equal to A into A. Right? But what if I am doing something complicated? And what if this requires some explanation? So instead of writing code first, I should write some text first, right? So I should go to this text option. See, the cursor is moved from here to here. So when you start out writing, some kind of notes, what do you put at the top? Folks, can you please mention that in the chat? What is there at the top when you're just starting to write something? Mention in the chat. Somebody in the classroom, you can also voice it out if that's fine. So when you're starting to write out something, what's the thing which you write at the top? After that, you start writing.
So title and something? Or
Yeah,
addition?
title.
Yeah.
Or we can say heading, right? We put a heading at the top. And after that, we start writing. Right? So the same thing can be done here. So if you notice this text section under live editor, see now since we have opened a live editor, these 3 tabs are additional. That has got open. So under normal, you can add a title. So let's say title is Introduction to Live Scripts. Okay. Now after heading, after the title, there are different hierarchies of heading depending on their font size. So let's do heading 1. Let's say in I will say like the live script takes you through some basic mathematical operations, right? So this is heading 1, slightly lower heading, heading 2, or maybe heading 3. Okay. So if you want to remove the this bold font, just revert to normal. So I will say like the section below, I will mention what a section is. Tries to compute sum of squares, right? Then I can move back to this. Now let's say if I execute this, how do I execute this? You can run section. So currently there is only one section, but you can create multiple sections. So how do you create section? You click on the section break. So what happens is this particular section, 1, 2, 3, these 3 lines and everything above it is a particular part. Like you can just execute these 3 chunks of code separately, and that will not affect, I mean, it will not directly affect the rest of the exit, like the sections which will be following this part. So since I have separated out this section from this one, all I have to do is run this particular section. So there are multiple ways. So if you only want to run a section, click on run section. If you want to run the entire code, click on run. Okay. As the description shows, it runs all sections. So if you want to run only a particular section, click on run section. If you want to run this particular section, you can click here, or you can click on this particular dashed blue lines. So you see C61. Now the value c is equal to 61, if you notice, is getting printed to the right. Okay. But what if you want to print it just below this section? That can also be done. So currently output is on right. This part is active, if you notice. But if you want to keep the output on inline, just click here. See, this comes right at the bottom. So it totally depends on your convenience. So this is about just basic mathematical scalar operations. Now, let's take these things forward and let's try to generate certain functions out of it. For example, say I want to generate a sine wave. So if I want to generate a sine wave, I need certain values of time, right? Because for every value of time, it will compute a sine value, corresponding sine value. So for that, I need like an array of timestamps, right? So let's say I define such an array, t is equal to, it will start from 0. It will take a step of 0.1 and it will end at 1. Both 0 and 1 included, right? So the array will look like, let me just print this out, it will be clear. 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and so on till. So 0.1 is pretty large. So let me just increase the limit 0 to 10. So around 101 values, right? More values. So this is an array. So if I quickly jump back to my workspace, you notice this variable is there. So if I double click on this workspace thing will open up. So this is what it looks like. 0, 0.1, 0.2, and so on. So in this way, you can actually investigate what the properties of the variables. Now, this is fine. What if I want to print out something like x, which is equal to a into sine of t? Okay, this a is already there in the workspace, if you notice, because I had defined it in the previous section. So it's there in the workspace. So a into sine t, if I run this, so I get another array where every array is which is basically 6 into sine of these values. So see, the first p value is 0. So 6 into sine 0, which is 0. Then 6 into sine 0.1. The values are in radians, of course. So in this way, we compute. So now, what if I want to plot this? So I can type plot x, okay, or plot t comma x. I want to have t on the x-axis or the x values on the y-axis. So if I do this, this is what my sine value looks like, right? Perfect sine. Now you can change quite a few properties of this plot. And to do this, you can either look at what this plot function is all about. So let's say you are using a certain function in MATLAB and you don't know what that particular function does. Then what you can do is just select it, right click on it, and click on help on that function. Okay. And that will open up a help documentation window. For example, if I go to command window, so plot of x comma t exactly is not a MATLAB command. If I type help plot, then and enter, then everything will be visible in this command window. And if you want to open up a doc window, just type doc plot. Then this online version will open up. So this is the documentation page for plot, and it shows you what are the possible syntaxes this particular command can have. Okay. And it will also show you examples, how to create plots and stuff. For example, say if you want like the red color, okay, you want the plot, the line plot to have a red color, but if you want the line plot to have different markers, so that can be changed using different properties of the plot function. In live script, however, there are easier ways to go about it. Okay. So in live script, all you have to do is select a task. Go to this task under live editor tab. Go to this task. Under this task drop down, you will find this create plot task. And there are many other tasks. For example, a lot of them are useful when you're doing machine learning. For example, in machine learning, and we will get to that in the second half, cleaning missing data or cleaning outlier data is required if you want good data to be fed to a model. So all these things don't require you to write a lot of codes, as we will see. But all you have to do is set the options properly and things will be taken care of on their own. For example, if I click on create plot, creating a task, it's loading. Okay. So what kind of plot do I want? First of all, I have only 2D data, right? So the 3D plots won't be applicable for me. So let's say I select just plot. So what is the X data? The T array, right? Along X-axis, you have the T array. And along Y-axis, you have the X array. And this is what is getting generated. Okay. So in this way, you can, create your own plots. You don't have to always write codes to do that. You can take help of these easy tasks, and they will execute the same. Like if you notice here, all these lines of code, the MATLAB itself is generating on its own. You don't have to worry about it. So it saves time when you are doing maybe generating some codes on the go, just to do some analysis. Right? Everything clear so far? Those who are in the chat can type yes. Those who are yeah, I hope it's clear to the folks who are attending in the classroom as well. So this is about generating basic plots and some basic commands. We'll slightly get into matrix operations. So let's try to create a section break. First of all, let's minimize this. And after this, maybe have a section break. Okay, so remove this task for now. Text. Yeah. So in this new section, I will. Sir, can you please repeat how to display the output below output? Yes. So do you okay? So do you want to know how to use the task option or just the plot option? Okay, so I'll just show you how the basic plot works. Yeah, thanks for mentioning that, Hempriya. So anyone who has questions, please raise your hand. Hempriya, since I am not able to look at the video, can you please relay the question to me so that I can answer them? That will be really helpful. Yeah, so regarding generating plots, just define the array, input array, define the function which you want to generate, and type plot t comma x. Okay, that will generate the plot for you. And if you want to know how the task is getting used, here you can introduce under task, go to create plot. Under create plot,
Sir,
choose the, yeah, please go ahead.
sir, I just wanted to know how do we display our result below our code, not to the right, just that.
Oh, right. Okay. So in that case, yeah, so if you notice at the right, there are three options, right? Output on right, output inline, and this height code. Just click on output inline. So let's say you are currently here. You are able to look at the plot to the right. Just click on output inline, which is at the center. So automatically it will get transferred right below the script. Does that answer your question?
Yes, sir, I understood. Thank you.
Awesome. So this is about using the task, like generating plots. Now, in MATLAB, we can do matrix-based operations really easily. And since we'll be delving into image processing in a while, a lot of that will be matrix-based operations. So let's quickly go through a few of them. So let's say I want to define a 3x3 matrix. So let's say it is capital A. How do I define it? First of all, put these square braces. First, you define the first row. Okay, so let's say that is 1, 3. So this is the first row of the matrix. I am defining a 3x3 matrix, maybe 1, 2, 3. Then I put a semicolon. Then I maybe put an enter so that it's easy to visualize. So 4, 5, 6. Again a semicolon. And then 7, 8, 9. Okay, pretty simple. This is the matrix. I just want to print it out as well. So if I go to text, maybe create a separate section out of it. Yeah, that will be cleaner. So here I can put some text, we can say that let's do some matrix based operations. Right. So 1, 2, 3, 4, 5, 6, 7, 8, 9 will be 1. And if I can run only this particular cell. See 3x3. Say you want to create the transpose of it. So what you can do is just type A underscore trans, which is nothing but A, then this apostrophe mark, right? This comma at the top, apostrophe. And if I run this, see, the first row becomes first column, second row becomes second column, third row becomes third column. You can do other things as well. For example, say we can add matrices. For example, say A. Let's say we define another one. Say B. B is equal to. Now let's say I want to define a random matrix. If I want to define a random matrix, there is this command called rand, R-A-N-D. And if I open, sorry, in this rand option, I have to mention the size. So let's say the size is 3. What does it print out? Yeah, so this basically prints this out. So what it actually does is, if you just pass 3, it automatically assumes that you are trying to generate a random matrix of a random square matrix of side 3, which means 3 cross 3. Okay, and this rand actually generates these samples or picks up these values from a uniform distribution. If you want to do it from a normal distribution, instead of rand, type rand n. The same thing. And inside this rand n command, you can put the parameters of the distribution as well. For example, say, what is the mean of the Gaussian distribution, or what is the sigma of the Gaussian distribution? That can also be done. Okay. So this is how you can generate different random matrices. Now let's say I want to add 2 matrices. So I'll create another, okay, maybe here itself. I'll create C, say that is equal to A plus B. So these two get added basically, right? See, 1 plus 1.4090 is 2.4090. So just matrix addition. You can also do matrix subtraction. Okay. Now you can do matrix multiplication, but there is a catch here. So let's put the multiplication sign here. Okay. It gives you certain values, right? On the other hand, there is another possible way to multiply 2 matrices. What if I put dot just to the left of this multiplication symbol, right? So A dot cross B, right? So something interesting happens. So A star B is not exactly same as A dot star B. Okay. Can anybody please mention the difference between these two? What does A star B does and what does A dot star B does? Do you know the difference between these two? Anyone? You can type in the chat. You can unmute yourself. Any way will work.
So
Let's say,
star
yeah.
B means term by term multiplication. As A dot star B means matrix multiplication.
Okay. Yeah, thanks for the response. Do others also feel the same, or do you think it's slightly different? One does matrix corresponding terms. Yes, which one is which? C1 is what?
A dot B is like scalar product and A star B is like vector product.
Yes, that's exactly correct. So when you do A star B, that is matrix multiplication. When you do A dot star B, that is basically element-wise element. So if you notice here, I had printed this value, like earlier it was A dot star B, right? So 1 into minus 0.0301, 4 into 1.0933, and stuff like that, right? So in this way, we can calculate. So in this way, we can differentiate, and this holds for anything. For example, you can do both, like depending on the application. You can also multiply matrices with maybe just vectors. For example, say if let me define another one, say small b. Small b is nothing but a 1D vector, right? Say 4, 2, 1, 2, something like that. Let's call it small b. And I want to do A into B. We calculate that. So this is creating some problem because B, like the shape of A is 3 cross 3. If I have to make it multiply with another one, it has to be 3 cross 1 and not 1 cross 3. So these shapes matter a lot. So if you pass A cross B star, then it will print it up, right? So 3 cross 3 into 3 cross 1 gives you a 3 cross 1 vector as answer. And you can do other operations as well. For example, say you can take inverse of something, inverse of A. If you do inverse of A, it might throw some error. Okay. Why is this warning showing up? Anyone? When we are trying to compute inverse of A, this is A, by the way. Any reason why this warning is showing up when we are trying to compute inverse of A? Non-invertible matrix, exactly. So the determinant of this one is 0. It's a singular matrix. So while computing, it throws some error. And that is exactly mentioned here. So all of this can be done. There are other matrix operations also that can be done. But I'll share some resources with you so that you can go through the documentation and understand some more, involved computations required in linear algebra or matrix operations. So with some background on matrix at this moment, let's try to do the first, command, like the first exercise. This one. Okay. One more thing that I forgot to mention was that you can actually clear things out. For example, say every time you are saving some variable, it gets saved in the workspace, right? So after a while, your workspace will be largely occupied. So if you want to clear them up, if you want to clear the variables up in the workspace, you can type clear all, enter in the MATLAB editor or in any command. It can be in script as well, it can be in live script as well. But basically this command clears up everything in the workspace. As you can notice here, there's nothing in the workspace at this moment. If you want to clear out this command window, as you can notice, we have done quite a few things here. If you want to clear this out, just type CLC, which is clear command line. Command line clear. If you enter this, command line is also clear. So whenever you are just starting afresh, right? It's recommended that you clear things. If there are certain figure windows that are open on your end, currently there are none. But if there were a few of those things which were open, close all, could have closed all those figure windows. Okay. So this is a way to start afresh. So before getting started, we will run this command. So clear bars basically clear variables from the workspace. And we have cleared everything, we have closed everything, we are just starting afresh. Now, we have a file called papers.png in every MATLAB installation, even in the online version. So what we will do is, we will try to read the file. We will try to look at the data. we will try to look at the image data. So to read the file, the command that we are going to need is imread. Okay. Again, same drill. If you are not sure how a function works, just select that, nothing else, only the name of the command, right click, help on imread. Okay. And this new documentation page will open up for you, which will show you how this command works, show you different examples around it and stuff. So we are trying to read this file, which is papers.png, papers as in chilies, and saving this in this variable I. Okay. And I will also display the image. So I'm loading the image and displaying the image. So this is what the image looks like. Okay. You have different peppers, red bell peppers, capsicum, stuff like that. But okay, I have saved it in a variable called I. But what does I look like? So you will get some hint if you just hover the cursor around it. So you can just see the values. Okay. They are 62, 63, 65, something like that. But how is this arranged? Really? So if I go to the workspace where my variable is stored, yeah, just give me some time. Yeah, I think there was some network issue. Just give me some time. Right. Okay, let me reshare it. Is the command window visible again? Can anyone confirm? Sorry, the live script. The live script visible again?
Yes, Pratyush.
Okay. So I'm reading the file and I'm showing it, but it gets saved as this variable, right? So what does this variable look like? If I go to workspace, this is what this variable looks like. Okay. So 384, 512 cross 3. So if I try to tally it with the image that I have, 384 is the length, 512 is the breadth. What about 3? Can anybody mention what does 3 signify?
As this is a color image, so it is RGB.
Right. So exactly. So basically, these 3 represents the different channels that we have for color. For color images, the most conventional form is RGB. So we have a red channel, a green channel, and a blue channel, and these 3 values. Okay. And they actually describe individual pixels. So if you notice the data type, this is UINT8, which means unassigned 8-bit integer. So image pixels are usually, they are usually expressed in terms of 8 bits. So the lowest value will be 0, highest value will be 255. So all those values will lie between these two extremal values. Okay. This is the size and this is the class. Class is UINT8, unassigned 8-bit integer, which is standard for any image. Okay. If you want to look at individual, just look at individual pixel values, you can take a look at here. Okay. Okay. Now, what we can do is, since we know the indices of individual pixels in the image, we can actually scrape out different parts of the image, different patches of the image. For example, say 1:5, 1:5, 1, which means I will go to the first channel, which is the red channel. In the red channel itself is a 2D matrix. So from the 2D matrix, I will just scrape out a 5x5 matrix. Okay, but the first one will be at the left top. Similarly, I can do this for the second channel, which is the green channel, and the third one, which is the blue channel. Okay, so in this way, I can actually extract out patches from the image. Because now these are just matrices, and I can do matrix-based operations. So what is the idea? From 0 to 255, 255 means completely bright, 0 means completely dark, and the values are usually in between these two extremal values. Okay. So now, since we have the image in the form of a matrix, it's really easy to do matrix-based operations on the image. Now let's say I want to brighten the image slightly. Okay. So what I can do is, if I increase the value of all the pixels, okay, then all the pixels will have a higher intensity. This means all the pixels will get brighter. And we will end up with this new image, or rather this new matrix, whose pixel values are actually 1.25 times of that of the corresponding pixel values of the original image. So I end up with this one. Okay. So this is slightly brighter. If you notice from the previous one, it's not so bright. Just look at this like white crease values. Here they are more, right? More white creases, which means they are clearly brighter. If I want to make it darker, why not multiply it with a fraction which is less than 1, right? If I multiply it with a fraction greater than 1, brighter, less than 1, darker. So if I do that, I'll end up with this one, right? This is clearly darker with compared to this. I can also resize images. For example, say I want to take an image and this image is really large in size and I have to resize it. We will see an application of resize when we are doing the deep learning part workshop in the second half. But if you are trying to resize it to a smaller shape, this basically means from the larger shape, you are kind of downsampling, right? You are picking up some pixels and leaving out the rest because you have less information now. The matrix size has gotten lower, which means you have less number of pixels, hence you are losing out of information. Hence, if you notice here, the image is not that sharp, right? It is slightly blurred, if you notice. Why is it blurred? Because it does not have a lot of information. And we have lost information because we have resized it to a smaller shape. Okay. This is what we will end up. Now, what if I want to look at a particular part of the image? So you see, what is end? End is basically the last value along a particular dimension. So let's say the image is of size 384, 512, right? If you notice the size. So if I put end along row, which is 384, it will give me 384 because that is the last index value along a row. Similarly, for a column, the last index value will be 512. So if I end at, so if I am only looking till end by 2, I am looking at half row wise and I am looking at half column wise. And I'm taking all the 3 channels by the way, which means I am looking at the top quarter. So end is an interesting way to refer to the last or the highest index value along a particular dimension. So I am looking at the top quarter, and this is what I end up. Okay, this is the top quarter. Now, under certain cases, I might have to convert my image to a grayscale image. What is the difference between a grayscale image and a color image? A color image has 3 channels, right? Red, green, and blue, whereas a grayscale image usually has only 1 channel. So it will look like this, black and like kind of like gray, black. So this is the black and white version or the gray version. Gray would be more appropriate, the gray version of the image. Now, let's say I have the image and I want to segment it out. How do I segment it out? There are multiple ways to segment it out, but let's say I do the most basic thing. What is the most basic thing? I set a threshold. I say that, okay, my pixel values are between 0 and 255. All the values which are greater than 127 or 100 or 200, whatever, all the values which are greater than a particular threshold, I will set those pixel values as white. The rest will be black. Okay. Then only the white pixels are of importance to me. So this is a very crude way of segmenting, where I just set a threshold of 100 maybe, and everything greater than or equal to 100 is bright, rest is dark. So from a grayscale image, we will go to a black and white image, a binary image. So this is what we will end up with. Right? See, there are no gray shades as such, only white or black. Because everything greater than or equal to 100 is now 255, which is absolute white, and less than 100 absolute black or absolute dark. So this is what we end up. We can do kind of similar things with color images also. In color images, really weird things are happening, because in color image, you have 3 channels. So when you say iseg is equal to 255, you are probably setting only one of the channels as 255 and retaining the rest. Okay. You are checking which one is greater than 100. If any of them is greater than 100, set it to 255, only that channel. Which is why you get this kind of weird, some of them are white, some of them are even purple, some of them are red, some of them are yellow. So in this particular exercise, we saw how to manipulate images, how to resize them, how to convert it to a grayscale, and finally, a very simple segmentation strategy, just a basic threshold. Any questions from this part? Anyone?
Anyone has questions here?
Yeah, please feel free to go ahead.
Anyone from
I
the
have a question.
online?
Sir, what is the algorithm running behind the scene for converting RGB image to grayscale?
Good question. So again, whenever we are facing any query, when we are trying to figure out what algorithm is behind this, so let's just select this, right click, help on RGB tool. So the documentation page will open up, similar things will show up. At the bottom, if you notice, the algorithms part has been mentioned. So for example, what it actually does is basically takes the R value, multiplies it with certain constant, like takes a linear combination of all the R, G, and B values, and that turns out to be the final value. So this is one strategy. So this is basically what is getting used. Does that answer your question?
Yes, sir. Thank you, sir.
Yeah. So the interesting thing about these docs is that, when for different commands or, for different examples, you can find different papers or different books that are cited in this section. For example, here the algorithm part has been mentioned. In certain examples, maybe the paper which was used to maybe realize this function, that will be mentioned. So you can go to that paper link, maybe read it up, to get more information. Right. So this is about the first example. Let's go back and try to do something slightly more advanced. So let's do some color detection. I will close the rest of the things. We need to save it. And I enlarge this. Again, same drill. Every time we are trying to do something new, just clear out everything. So we clear the workspace and start again. Now, there is another image called lighthouse.png. If I want to see it, this is the image. Okay. So it is a lighthouse. It is standing on this green, this field, and you have certain houses at the back. Now, I just want to detect colors in this particular image. Okay, I want to detect what is the amount of redness in this image, or what is the amount of blueness, the greenness in this image. So for images, it's easier because you have different channels for different colors. Right? And when they get mixed, they are giving you different shades of different colors. So there are three basic colors, R, G, and B. So if I want to only look at the If I only want to look at the red color, I will choose channel 1. For green, I'll choose channel 2. I'll choose channel 3. And here is a detect color function that we have written, which helps us to do that. So I'll explain what this detect color function is all about. First, let's look at the images. So this is red. So let's look at the red parts. Right. See, this lighthouse is actually white in color. Right? So something which is white in color consists of all the components. So it's basically 255, 255, and 255. So any color, like in all these three channels, red, green, and blue, they will be colored by, they will be deep in color, right? They will be detected. Which is why for red, this part is red because white consists of a very high amount of red, white consists of high amount of green, and white consists of high amount of. Okay. On the other hand, see the background is pretty much blue. The background is not getting captured. Like only the white clouds are getting red in color, right? Only the white clouds are getting green in color. But the entire background is blue in color because the sky is predominantly blue, right? Same thing about other colors as well. Green, where is the green color? For example, in the ground is green in color. So here no green, here some green. And here, like it depends on the intensity also. Or it also depends on the kind of threshold. For example, we have set a threshold to 175. In the detect color function, we have defined a function here. So in this detect color function that we are using to detect the colors, we have set a threshold of 175, which is fairly high. So if you reduce the threshold, maybe these regions will again get filled up by green. Okay. So anything which is greater than threshold. So in channel 1, if it is greater than the 175 value, it is deep red, otherwise black. For blue, it is deep blue, otherwise black. For green, it is deep green, otherwise black. But it totally depends on the threshold. And this is actually how you can define functions. So let's say you are using your own function in a particular live script. So what you have to do is define it at the bottom of the script like this: function, output of the function equals to name of the function and inputs. It's basically like y is equal to fx, or y is equal to f of x1 comma x2. So x1, x2 are the inputs, y1 is the output, f is the function. And inside this body, you basically define the function. And you return this undetected value. So this is how you can actually select, like, detect colors in the image. Does this part make sense? Can type yes in the chat if so. If any questions, feel free to go ahead. Any questions? Does this part make sense? Okay. Yeah, I hope this part makes sense to you. If you have any questions, again, feel free to chime in. Just unmute yourself or just type it in the chat and we'll be.
If anyone has questions, just let me know. I'll give the mic to you. Participants in the online can unmute themselves and
Yeah, exactly.
ask.
Yeah. Okay. I think this was helpful. Let's move on to the next part, which is around maybe edge detection. We'll try to detect edges in the image. So before getting started, we can just clear things up slightly because this is a new image now. So we don't have to clear everything, just maybe clear all. Remove this thing. In edge detection, first of all, we will read the image. These are basically coins, right? Circular coins of different shape. We read it. This is a grayscale image, right? 246,300. So no 3 channels, no color image now, only grayscale. Now we can detect edges using different kind of functions. For example, if I had written, say, first of all, let's say I want to detect edges using the Sobel method. Okay, Sobel edge detector, or I am using the canny edge detector. And after doing so, I can show them side by side using this command IMShowPair. How do I show them? In a montage kind of a format. So if I run this, so this is what we have. On the left, we have Sobel. On the right, we have Canny. So if you notice, in terms of extracting more subtler details in the image, Kenny is doing better, right? Because if you look at this particular coin, it has this the image of a particular monument, right? It is doing a better job. It is at least capturing those edges around those monuments. On the other hand, Sobel, not that much. So it depends on the kind of application where you are trying to use edge detection. So the thing with Canny is if you have a lot of noise, that will also get captured. So we have to be careful while choosing different kind of filters. And the command is basically edge. Again, to find out what this edge command does, just select, right click, help on edge. So you have different methods, right? See, if I go to this command, if I click here and go to this method option, see there are these many number of filters that we can apply. Okay. And it also gives you a short description of what the individual is. Sobel, Prewitt, Roberts, we have used Sobel and Kenny, but there are other options. You can also use different thresholds. As I was mentioning, Kenny, the problem with Kenny edge detection is that if the threshold is low, it will also capture different noises in the image. If there is a lot of noise in the image, the final result will not be that accurate. So you can even select certain thresholds for the sensitivity. So if you have very high sensitivity, noises will get captured. If you have low sensitivity, you can reject noise. And stuff like that. So there are many algorithms that are getting used, but the basic idea is pretty much simple. So for example, if you notice, I am taking the papers image again. I'm selecting out a part of it and I'm showing you the image. So if you are trying to process it on a color image, so all the methods, this Sobel method, this Canny method, they are working on grayscale image, right? So on color image, it won't work that well. So we have to convert it to grayscale image first and then do the operation. So what are we doing? We are converting RGB to gray for this color image, this image, converting it to a grayscale image. And what are we trying to do? We are trying to do an element-wise differentiation between these matrices. Okay. So when you do element-wise differentiation, for example, say maybe say I am at location I1, 1 and I look at the image at I1, 2 and I try to subtract I1, 1 from I1, 2, that will be the difference. And these difference values will actually be stored as an array. Okay. So then the array kind of looks like this. This is just plain differentiation. We have not applied any fancy edge detection methods. We have just taken a matrix, done element-wise differentiation, and this is what we end up with. Okay, so if you notice here, the edges are kind of visible, right? This is the edge. This is another edge. This is another edge. So the outline of individual objects are clearly visible. Now, from this image, what can we do? We can again set a manual threshold. We can say that, okay, edges which are kind of thick, we will only call them edges. Edges which are not so thick, we can just discard them. And that's not a bad strategy because a lot of these values might just be noise. Okay, we might be just mistaking them for edges. So in order to reject them, we can do this thresholding after differentiation. And we end up with something like this. Okay. So we actually end up with these thick edges kind of. But this is just a brief idea, a rudimentary method. So all the algorithms like Sobel or Canny, they are, I mean, they use a lot of more computational techniques so that your edges are more accurate. Okay. For example, here, if you notice, still a lot of noise is persisting, right? So how do you remove them, right? So if you remove them, the edges will be exactly sharp, right? They will be extremely sharp and you will be able to identify them easily. So then these algorithms actually use different techniques like non-maximal suppression, or they compute gradients across a larger region, spatial region, so that the results are kind of not too noisy. Right? In this way, they are able to address those challenges. But this part, this differentiation part or the subtraction part forms the basis of different edge detection algorithms. So we finally end up with this one, Sobel and Canny. So this is Canny for the paper image. This is the Sobel for the paper image. So this is about how we can do edge detection. Does this part make sense? You can mention yes in the chat if you are online. Participants who are attending from the classroom, if you have any questions, feel free to let us know.
If anyone has any questions, do let us know. Participants in the online can unmute themselves.
Yeah, sure. Cool. Yeah, I think I got a few yeses in the chat. Thanks a lot for that. I hope this part was helpful. One more demo which I was planning to do was around cell segmentation. If I open this, so now we will be using what we did in edge detection, and we will be doing something called morphology to get better results on images, or to do some kind of cell segmentation. Does anyone know what morphological operations are? Can you type in the chat or maybe unmute yourself?
Anyone wants to answer?
Morphological operations in terms of image processing. Anyone? I mean, I mean, I will explain it anyway. So, but just curious to know if some of you are aware of what morphological operations.
Is it like characteristics of the image or?
Yes, it uses certain features, certain properties of image, but it mostly works on binary images. So I'll quickly open Paint and show you what it's like. Is the Paint window visible? Since I don't have a
Yes.
yeah, since I don't have a blackboard in front of me, Paint is the closest thing. So let's say we have how do I select an object? Or say, okay, I use a brush, this one. So this is some kind of an object, right? I'm just randomly drawing stuff. And say this part is filled. This part is filled with, okay, sorry. So this is black and white image only. Okay, this one. color size is this one. I'll remove. Yeah. So let's say I have this particular box. It's a black and white image. And let's say I have another box, which is a black and white. Now, morphological operations are basically set theory-based operations. So the operations that we have done previously are mostly matrix-based operations, right? We are doing some computations. We are either differentiating or maybe adding stuff, things like that. Morphological operations will take into consideration the intersection or the or the end of different images or different pixels. For example, say at this particular pixel, you have two black pixels, right? One from this image and the one from this image. So now it's black and white. So 0 and 255. So I can just call it 0 and 1 now because it's binary, right? Either on or off. So 0 and 1. So if I have only binary numbers, I can do AND or OR between them. I can take not of 1. I can take AND of 2 binary numbers. I can take OR of 2 binary numbers. I can take intersection and then complements, things like that. So what will happen is if I say take AND of these two and then take a complement, then this particular pixel will become white, right? Because black and black, 0 and 0 is 0, complement of 0 is 1. So this black pixel will become white. Similarly, this black pixel will become white. So the basic idea is to have set theory-based operations instead of matrix-based computations. And these are only applicable for binary images because only binary images have this high and low possible states. Others have a continuum, so it's difficult to do set theory-based things there. Does this make sense to all of you? Can you quickly put yes if so? If you have any doubts, feel free to go ahead. Great. I see a few yeses. I hope folks who are attending it on the classroom, they are also able to get. So I'll just quickly close the window. So now there is this popular algorithms called erosion and dilation, right? What is erosion and dilation? So when we say erosion in geography, it basically means loss of material, right? So in image, erosion is basically loss of white pixels in a black and white image. Okay. And what is dilation? Exactly the opposite of that. It means you already had a patch of white pixels. It is just dilating or expanding. It means more and more pixels are becoming white. So erosion basically means loss of white pixels. Dilation basically means expansion of white pixels. And these two are again set theory-based operations. And we will use them. So first of all, let's read the image. There is an image called cell.tif. We will show it. This is the image. Okay. It was captured by someone called Alan Partin from Johns Hopkins University. So first of all, what do we want to detect? Basically, we want to detect this particular cell, right? This is not exactly, this is not a full cell. It has been cut off. So our expectation is that this particular cell gets detected perfectly. This part, this is not the entirety of a cell, so we can reject it as well. Only this part is important. Now, let's do some simple edge detection. First, we will use Sobel, and we are using a fudge factor. Fudge factor basically decides the sensitivity of the edge detection algorithm. So we end up with this thing. Okay, so we end up with a black and white image, which is basically a binary gradient mask. It's basically the edge equivalent of the image. So we only extract the edges from this image and we end up with this thing. But clearly this is not a continuous, this is just a collection of edges, right? This is not a continuous image. If what we had actually wanted was a continuum of white pixels here, that would have been the entire cell. So what we will do something called dilation. Totally makes sense, because if we are doing erosion, then we are losing information, right? All the white pixels that are already there, we will lose them. So instead, what we want to do is we want to dilate this thing so that the white pixels are increased and we are able to fill up this entire region with white pixels. So what are we doing? We are taking two structural elements. So structural elements are extremely important because these structural elements actually move around an image and do certain operations. So again, if I have to open Paint, let's quickly show. So let's say you have an image, something like this. So what the structural element will do is like, say, is like this. This is a structural element, and it will move like this. First from top corner to the right hand corner, then move slightly lower, again move to the right. Again move slightly lower, again move to the right. Again move slightly lower, move to the right, and this will go on. Okay. What will happen is, in this way, it will cover all the pixels by these motions and will perform erosion or dilation or whatever morphological operation is there on the image. Okay, so we have to define the structural element first, and this is the image. So we are dilating it. We are using two structural elements. One is a line, which is at 90-degree orientation with respect to horizontal, and another is 0 degree. So basically one horizontal line, one vertical line, which will basically move through this entire image. And if I click here, okay, so I have to define this first. Then if I do it, see, it gets filled up, right? Look at the earlier image, a lot of black pixels. When we are dilating it, it gets filled up clearly. But still, there are certain black patches which needs to get filled up. So what will we do? We are using this command called imfill. The command that we used for dilate is imdilate. We used the black and white image and we took the structural elements. So the first one gets executed first, the 90, the vertical line, and then the horizontal line. And we get this dilated image. Now, on this dilated image, there are certain black holes, right? Small holes, small patches. So we will fill them up with holes. So what this actually does is, it actually looks at the connectivity. It looks at the neighborhood. So for a white pixel, it looks at the neighborhood and checks if there are certain black pixels here. If there are enough black pixels in the neighborhood, it will just fill it up with white pixels. So based on that principle, it will fill out holes and you end up with this one, which is why using imfill with the dilated image and with the idea of filling out holes, we get this filled up image. So if you compare, this is the one which has a lot of black patches. This has all those black patches filled. Now, in the border, we see this patch. but this is not an entire cell, right? So we might want to remove this. Okay. So we are using this command im clear border, this image, and this connectivity. Connectivity means it looks at the image and looks at its 4 immediate neighbors. Okay, so in an image, you have one neighbor at the top, one at the bottom, one at the left, one at the right. By looking at the neighborhood, it decides whether I have to keep this white pixels inside the image or whether I have to remove this. Okay, so objects which are not well connected get removed. And that is the idea behind cleaning up the border image, like cleaning up the border patches and getting a clearer version of the image. So what do we obtain? We obtain this, right? The border is gone. But still, like if you notice here, not that smooth, right? Not that smooth, because just notice the original image. Extremely smooth, right? So we need to smoothen out this image further. So for smoothening things out, we should get rid of excess white pixels. Now you see, here you have these rough patches. So to smooth things out, I have to remove some of the white pixels, right? I have to remove this patch maybe, some of these rough patches maybe. In this way, it will become smoother. So for removing white pixels, instead of dilation, I will use erosion. And I will use this structural element, which is diamond shaped. And once that is done, better, right? See, all these small things are gone. Small patches are gone. I mean, if you want to further smoothen it out, you can choose a structural element of higher dimension, but it's up to you how much information you want to read. Now, see the segmented image. I can use this as a mask, right? So if I impose this on an image, actual black and actual grayscale image, I can say that, okay, the pixels which are white in color or the pixels which have a value 1, make them blue. The rest can retain their original color. So I can use this segmented image as a mask, impose it on the original image, or rather overlay it on the original image and get the segmented cell. So this is the segment. So this is how, I mean, this is a way to segment out. This is a very, this is a simple way, I would say, to segment out images. There are more complicated ways as well, but in this particular part, we understood how we can use segmentation, how to use edge detection, how to use maybe morphological operations, because we used quite a bit of dilation and erosion, right? And also filling to obtain the segmented out cell pixels from this image. Right? So this brings me to the end of, okay, another thing, if you want to just draw a perimeter around it, you can use this BW perim, and this will give you the perimeter pixels. And you can color it as white. As a result, if you just want the outline, this is the outline. Because from this black and white mask, I can understand which are my perimeters, right? By using this perimeter pixel values, I can draw the perimeter for around the original image to segment out the mask, to segment out the cells. Great. Does this part make sense? Any questions? You can type yes, or you can type out your questions also. If this part made sense to you in the chat, you can also unmute, ask your question. That will also.
Hi, Pratyush. I have one question.
Yeah.
Like these image processing techniques, whatever we use, can
Yeah.
it be implemented in any kind of 2D data? Just like if we have a 2D Fourier spectrum, can
Yep.
we use this in that?
Yeah, that can definitely be done. So the idea here is we are in the original image, we are at least able to, get an idea of, okay, this will, what the segmentation will look like. And here the background is pretty, like there is not a lot going on in the background. So if we are able to make sure that the foreground kind of like there is not a lot of noise going on in the background, at least for these kind of images, the same techniques can be applied and it will give you good results. But yeah, but it depends on the use case. I think one thing we have to make sure is maybe do some pre-processing, maybe remove some noise from the image so that the background and foreground are at least visually, discernible. In that way, we
Okay.
can.
Okay, but the image has values from 0 to 255.
Right.
But if we have a 2D spectrum or say reflectivity values of radar, so
Yeah.
that will have value ranging in negative also. So
Right.
how to, and that value signifies some kind of properties of that whatever phenomena happening over there. So in that case, how to preserve that values? Means if we can scale it into this image format, but
Right.
means will the value will be preserved or no? Means like say if you
Right, good question. So one thing is that the techniques that we are using, right, they will mostly work on unsigned 8-bit integer type data. So if we have negative values, maybe converting them to such a format would be helpful. For radar or for different other domains where we have values which is not within the 0 to 255 range, maybe. Yeah, I think I can share a few resources later, if, how that can be done. But one thing I can say here is that these techniques that we have discussed works mostly for unsigned 8-bit integer values only. So that might create some error if the values are not in that range. But yeah, but I can share some resources to figure out how that can be done if there are any alternate ways to go about it.
thanks.
Sure.
Any other
Thank you.
questions?
Any other questions?
Pratyush, can we like end up somewhere here
Yeah,
so
right,
that
right. Yeah.
yeah,
I'll also
thank you.
planning.
Yeah,
Yeah,
thank you.
I think we are already past, we are already past
Yeah,
12
because
30.
our list works till 2 o'clock only. So,
Yeah, right. So
so
yeah,
if
we will
there is
continue.
anything we can continue in the afternoon session, I think we can add it up to the afternoon
Yeah, right.
session.
Definitely. We can continue in the afternoon session. And in the afternoon, we will be covering mostly deep learning. So please join that session as well. And if you have any questions from this particular session, you can continue with those questions in the next session as well. But thanks everyone for joining in the first session. Let's take some break. We will again come back at 2:30 and continue with deep learning.
Yeah,
Right?
thanks, Pratyush. The link will be open, so
yeah,
people in the online, once they have their lunch, can join again.
sure.
Thanks, Pratyush. We'll meet back at 2:30, maybe 2:30.
Sure. Yeah. I'll be in the chat, I guess. If you have any questions, just drop it. I'll also go and have my lunch, and when I come back, I'll answer them.
Yeah, please. To the participants here in the offline, so come back at the session will again start at 2:30 sharply. So come back before that, and at the end of the session, you will collect your certificates, and the refreshments will be given. So please try to come back at 2:30.
Yeah, sure.
Thanks everyone for joining. Let's meet at 2:30. Bye.
Hello, Pratyush?
Yes, Hemant.
Yeah, I think so. It's good to start. Maybe 2 or 3 are left out, but I think so. We can start.
Sure. Yeah, we'll get started. So, right. So, welcome back, everyone, to the second part for today's session. We will be mostly covering deep learning in this part. And we will take you through some examples on we'll just try to do a hands-on on how to do deep learning, do the training from beginning to end, the entire thing. So let me quickly share my screen. Yeah, do let me know if the screen is visible. Anyone confirm?
Now it's visible, Pratyush.
Yeah, great, thanks. Right, so we will see how we can apply deep learning concepts in science and engineering with MATLAB and Simulink. So just some educational background before I get started. I did my bachelor's in electrical engineering from Jadavpur University. I did my master's in signal processing, from IIT Guwahati, and currently I'm interested in domains like computer vision, machine learning, deep learning, and their application in computer vision. LiDAR processing, which is like a technology to find the 3D, like to get a 3D scan of objects and then apply maybe deep learning and machine learning to them. So this, I guess all of you have done already. This link has already been shared. It's the same link. Just want to show you that in the online version. So earlier in this particular file folder that I shared, which is IIT Indore exercise files, we only covered the IPCB part, like some parts of the IPCB folder. And apart from this IPCB one, there is this deep learning folder as well. So the demos that are already there, we will be covering that in this part. And apart from that, there is actually like the part that involves the end-to-end deep learning workflow from getting images and like doing transfer learning on a particular image data set that we are going to follow from one of the on-ramps that we already have. So please stay with me. We will be first discussing certain concepts around machine learning, what is deep learning, why we need deep learning, how deep learning is a part of machine learning, and so on. So let's get started. So before I dive into what is deep learning, as it explains here, it's a subset of machine learning with automatic feature extraction. So the question to the audience is, what is machine learning according to you? So those who are in the room, they can unmute, like they can speak up. Those who are in the chat, they can mention it in the chat. They can also unmute themselves. But feel free to answer the question. So what do you think is machine learning?
Anyone wants to answer? You can speak. Mics are also there. So from audience, they can unmute themselves if they want to answer.
Right. Yeah. Any answers? What do you think? Yeah.
Yeah. The question, can you repeat it?
Yeah. So the question is, what is? I can see a few responses, but just to repeat the question, what is machine learning according to you? What do you understand? So we use like we are using machine learning in different of our projects. In like industries are using it, academia is using it. But what is machine learning according to you? So I can see a few responses: making machines smart enough to make decisions and also analyze large data sets that is manually very complex. Good answer, Rohan. Learning of machine through assimilation and accumulation of new knowledge in pre-existing schema. Nice, really nice. So yes, I think these two answers pretty much explain what machine learning is all about. So a machine, it's like you have a machine, and the machine can be a computer or any processing unit which is able to identify patterns properly, and it is able to identify patterns within data using certain statistical techniques. Okay, so in that sense, machine learning is a subset of AI. So AI is about imparting intelligence to maybe inanimate objects, say a computer, and it's a very broad field, and it might not always consist of statistical techniques. It's a very broad field. It might consist of if else based rules as well. Okay. There are different other techniques. Whereas machine learning deals with uh, statistical techniques mostly to identify patterns within data, and by gaining that knowledge of patterns, trying to make certain predictions. Right now, here is an example. So let's say we have a task at hand. We have been told to discriminate between different kind of furnitures. Okay. So let's say we have a sofa, let's say we have a chair, let's say we have a table. Now, if somebody has to identify which one is which, the person can do that by just visually looking at the furnitures and making some calculations. For example, for a chair, maybe you can recline on a chair. You can also recline on a sofa, but on a table you can't do that, right? On the other hand, a sofa, the surface is extremely, leathery or velvety. The same might not be applicable for a chair or maybe a table, right? So all these properties, the smoothness of the surface, or whether it has a recliner or not, if we can measure them somehow, then these measurements become features. Okay, so these features actually identify with the property of that particular furniture. For example, you can have the feature for smoothness of surface, how many legs, or maybe whether it has a drawer or not. So if you were able to measure these individual features, so then you can create a feature vector, right? Let's say an n-dimensional vector where individual dimensions refer to individual features, right? And if you are able to quantify these properties into a feature, you can feed it to a machine learning model, and the machine learning model will be able to identify patterns from those feature vectors and will be able to make certain predictions after that. Okay. Does this make sense to you? If yes, can you type yes in the chat? Does this part make sense? How machine learning works in general? Any response in the chat? If you have any questions around this explanation, feel free to go ahead.
There is not any response in the chat box I can see.
Yeah.
Is that clear to you who are present? Yeah, I think so. Here the audience are clear.
Okay, awesome. Right. So this is about machine learning. So machine learning essentially deals with good features.
Sorry to interrupt. Can you just
Sure.
hold on for a second?
Sure.
Actually, the screen went off here. Just give me a second. And
Okay, sure. Please take it. Just let me know once the screen comes.
Hello, Pratyush. Can you hear us?
Yes, yeah, I can hear you now.
Okay, sorry for the trouble. Actually, the projector went off here. Now you
Oh,
can
sure, sure.
start sharing, I think.
Right. Yeah, sure. The camera was working last time. Is it like is that
Okay.
causing some problem?
Now,
I
okay.
mean, if it's an issue, I mean, it's fine. If that
I'll
takes some
start
time.
it.
I think in the meanwhile, I can get started. Yeah, now it's
Okay. Yeah.
great. Yeah, let me just continue from where we left off. The screen is visible, right?
Yes,
Let me
Pratyush.
know. Okay. Right. So we were discussing about machine learning. So the idea is that the features, if you have good features, your machine learning will do well, right? So these features often are handcrafted, which means say you are an expert in certain domain. For example, I took the example of furniture. Maybe you know how furniture design works. So in that case, picking up good features by looking at furnitures, that can be done pretty well by you. If you are an expert in uh, say power systems, then maybe extracting good features for doing certain predictions around power systems, you can do it because you are a domain expert. But there are scenarios where we like getting good features is slightly difficult because we don't know which features would be the best to discriminate between certain classes. So let's extend that example for furnitures. So in our previous task, we tried to discriminate between different furnitures, right? Say chairs, or say tables, or say sofas, stuff like that. Right? Now, what if you are given only chairs? You are given only chairs, but now the task is to identify which brand does a particular chair belong to. For example, say the chair might belong to, say, Cello. It might belong to, say, IKEA, right? It might belong to Nilkamal or some other furniture brand. Right? So all chairs have, 4 legs. There is this surface on which you can recline. This is common for all the chairs. But how do you discriminate them, right? Because then those features which can be easily identified, they will not work because they are pretty much the same for maybe all the chairs. Then what you have to do is to get good feature, you need to automate that process of extracting good features. So you cannot let yourself decide features now. You can rather let the machine learning model itself decide good features for itself so that it is able to discriminate between different classes properly. Okay. And these techniques where automatic feature extraction happens, they mostly can come under deep learning. Okay. So deep learning is a subset of machine learning. Here also we are kind of using statistical techniques, but deep learning usually deals with a class of machine learning algorithms, which are called artificial neural networks. And the features are automatically extracted from the data itself. We don't need domain experts as such. I mean, we don't need much human intervention as such. That's how I put it. Does this like difference between deep learning, machine learning, and AI make sense? Can you please type yes in the chat if so? Yeah, what if yeses? Those who are in the classroom, do I make sense? Do you have any question on this?
Does someone have any questions? I don't think so, Pratyush. You can carry on.
Sure. Great. So what is the deep learning workflow then? So there are 3 parts. The first part is preparing data. So the data must be labeled and pre-processed first, because if your data is not pre-processed, if there is say some noise in the data, there's some missing data points, then your machine learning model might not be able to, identify the trends properly. It might be slightly biased towards a certain class. It will make wrong predictions, stuff like that. Build a neural network that learns from the data set. We have to train a model. When we say train a model, we basically mean that we have to build the model and try to find some kind of optimal parameters, which we'll get to in a while, for which a certain loss function is minimized. So the idea is, let's say you have certain data. Let's say I have data for, again, Nilkamal, IKEA, and Cello, like data around those chairs. And I have extracted good features, like the deep learning model has itself identified good features and done prediction, like was able to identify the patterns. So the training is the process where you try to find the parameters of the model, which is able to map the input to the output perfectly, or not exactly perfectly, but extremely close. So when that happens after training the model, if some new data comes to the model, it will be able to do certain predictions out of it. And the final step is deployment. So let's say you already have the model. What if you want to deploy it on a system? For example, let's say you have a deep learning model and you want to deploy it on an autonomous vehicle, so that deep learning model becomes the vision system, like is able to predict whatever objects are there in the street, right? So if the autonomous car is navigating around the street and it is getting the data around its environment from a camera, the deep learning model should be able to identify which part of the image refers to which object. So then it will become slightly smart. Okay, it is able to make sense of the environment now, and it is able to navigate in a smarter manner without causing much accidents. So in this way, you can deploy it on certain chips, which is part of a larger system. So we have solutions for different domains, not only images. We are using it for text analytics. We are using it for audio processing, sensor data analysis, LiDAR I mentioned, like for 3D scans of human brains or stuff like that, certain medical imaging applications. Also control design. So nowadays, a domain which is really generating a lot of buzz, a lot of research is happening in that field, is reinforcement learning, which is a combination of traditional control systems and deep learning. So we have solutions for that as well. So deep learning is used in different fields, and like we are exploring more and more, like for different kinds of data, it can be used. So deep learning models are essentially neural networks. What are neural networks? So neural networks are basically a way to, it's an artificial model of our neurons, the way our neurons are connected and they pass information. So it's like an artificial version of that. So when we say deep neural network, it basically means that it has an input layer, it has an output layer, and in between these two, there are a lot of hidden layers. More the hidden layers, deeper the network is. Okay? And more the hidden layers, more will be the number of parameters. So what happens is when you try to train the network, right, it's able to learn, or it's able to optimize these parameters of this model and is able to make better predictions. Okay. When data is passed through this network, these parameters, which are basically these connections, they get updated, and accordingly, your neural network is able to get better and better at making predictions. So training is extremely important. Now, we will try to do some simple steps we will try to see how we can use neural network to classify an image using just 5 or 6 lines of code. So we go back to the online version. Go back to the online version. So in deep learning, we open number 1, deep learning in 6 lines. I hope all of you are able to find this one. So there are 2 things, 2 files. One is work and solution. So we will try to do it hands-on. So we will write codes now. Okay. I hope this file is accessible to you. Just to repeat where you can find it, under deep learning, under number 1, deep learning in 6 lines, open work deep learning in 6 lines. Okay. Were you able to open the file? Quick yes in the chat before.
I hope everyone can able to access it.
Can see a few yeses. Yeah, I hope those who are attending, I hope you are able to access the live script, which is deep learning in 6 lines of code work. So first, to do this, we are actually using a pre-trained model. So what is a pre-trained model? A pre-trained model is a deep learning model. So currently we don't know what is there inside the model, but we can treat it like a black box. So what it basically does is it takes an image and says whose image it is or what is the object in the image. Okay. So for that we are using a pre-trained model called AlexNet, which is trained on a particular data set called ImageNet. Okay. So ImageNet is a very large database, consists of around millions of images, and it has around 1,000 categories. Right. So first of all, I need to save an instance of AlexNet. So I will define net as AlexNet. Okay. So AlexNet is one instance of this network, AlexNet, and I'm saving it as this variable net. It takes some time and it is done. We'll view the network layers after a while. So we have the network with us now. We have the deep learning model with us now. What else do we need? We need an image on which we can run the prediction. Right? So we will again load this papers image. So let's say IMG is IMRead and name of the file. What is the name of the file? Papers.png. Right? And I will again, after reading, I always reveal the image. So I will do I'm sure. Right? This is the one which we saw in the first session as well. This is the image for papers. Right. Now, I have the image. In this exercise, we are not training anything. We are just going to do the prediction. So for doing the prediction, we need to use this classify function. So here it mentions resize the image for AlexNet requirements and so on. Let's see what happens if we don't resize it. Let's not resize it first, and let's try to get the predictions right away. So let's say we have the image, we have the network. Let's try to say just pass it. See, it shows an error. Okay. Incorrect input size. The input images must have a size of 227, 227, Now, let's go to the workspace variable, which is this net, which is something we defined, right? So if we go to this net, this is opening up. Let's shorten this slightly. See, under layers, it has 25 layers. Okay. And if you look at the layers, there are 25 different layers and so on. The first layer is called an image input layer. And if I double click on it, see the size is, input size is 227, 227,3. So this is the size of the image that the network accepts. If it does not get an image of this size, it will definitely throw an error. So we have to make sure that we resize the image every time before feeding into the network. So for doing that, let's go back to the script. And let's try to resize it. So we will say img resize im resize image. And what is the shape? 227, 227, 3, right? Because there are 3 channels. But if it's a color image, MATLAB automatically assumes that the third value will be 3. So we can only pass 227, 227 because it's a color image. And that is how the im resize function works. So you can put a semicolon here. Yeah. So in the first one, it might take some time, but finally it is able to classify. So the class is bell pepper, right? So how is it able to right away say that it is bell pepper? Whereas I have not put any information around what this image is all about. So the idea is this particular network, which is AlexNet, has been trained on images of several bell peppers while it was being trained on the ImageNet dataset. So when it got to see, like this is pretty much how we learn, right? We learn through experience. So if we look at pictures of something, we will get to identify that, okay, this picture belongs to this object. So the same thing happens for image, this AlexNet as well. It has seen multiple images of bell peppers while it was being trained. And from there, it was able to conclude like, okay, maybe if it has a color red, or if it has this kind of a shape, the shape of chilies, then this might be a pepper. Okay. Now, one thing which we can also do here is actually visualize this particular network. So for that, we can use this command, analyze network net. So we can actually visualize what this looks like. Okay. See, this is what the network actually looks like. It starts from a data input layer, then one conv, one relu, one norm. We will get into all of these in a short while. But this is what is the entire description of all the layers. So the image input, how many activations are there, how many convolution parameters are there, how many weights are there, how many biases are there. So overall, you have 60.9 million parameters. These many number of parameters are required because the task is also difficult, right? You have around 1,000 classes. So among 1,000 classes, you are able to discriminate. And this is a fairly, I mean, it's a deep network, but there are deeper networks than this one, right? So I would say that even like million parameters are not a very uncommon thing in deep learning. We get millions and billions of parameters for really complicated networks. But we can actually visualize and try to see which layer refers to what, how many parameters are there and stuff. So this is about just the prediction part. We have not trained anything as such. But is this part making sense to all of you? Yes or no again?
Pratyush, so when we are loading this AlexNet, the weights, everything is loaded.
Yeah.
It's ready to.
Right, exactly. In fact, yeah, thanks you brought it up. So if you go to this net object, right? If we go to layers, if we go to, say convolution 2D layer. Right? So if you notice, we have weights and biases. If you click on them, you'll actually get to see the values of the weights and biases for individual layers. This can also be done. But whenever we are loading the network, we are loading the network architecture as well as the parameters, both.
Thanks, Pratyush. Anyone has any more doubts on this?
Cool. I hope this part makes sense. And if you have no questions, I can proceed to the next part.
Anyone has any questions on whatever has been done? I think so. That's clear, Pratyush.
Yeah, sure. Yeah, thanks for letting me. Right. So proceed further. We can also build networks from scratch, or we can use pre-trained models. Okay. So we will see an example where we will be. Actually, we will probably see two examples where we will again be using a pre-trained model, and we will also build a network from scratch. But pre-trained models have an advantage in the sense that, first of all, it has already been trained on a large number of images. And if you are using it on your own data set, and those images are kind of similar to the images on which it was initially trained, then you might get really good predictions out of that network, out of that pre-trained network. So we have support for all of these. There are more networks also for which we have support. And we have already seen AlexNet, right? So we will see one more network in the latter part of today's session. So these are some models on which we can get started with, because these are not 2D. For example, VGG16 is only 16 layer deep. VG19 is 19 layer. AlexNet is 25, as you saw. GoogleNet is also not too deep. ResNet 18 and others have some specific applications. For example, object detection. For example, say in the earlier image, we only saw that, okay, the image consists of bell peppers. But where exactly is the bell pepper located in the image? What are the coordinates? For those kind of applications, we can use these networks. And SqueezeNet, MobileNet, V2, these are actually lightweight, computationally slightly efficient. So if you are using a hardware which cannot do a lot of computations in a fast manner, feel free to go ahead with these three options. So this is a way of saying, okay, which network to use in which kind of applications. So these three we have already seen. Pre-trained models aren't always enough. We might have to build and train networks from scratch. We will do that in a while. But before that, let's try to understand what are the building blocks of such a network or such a model. So when we are using it in terms like for image processing or computer vision based applications, the most widely used network is called CNN, which is a convolutional neural network. So a convolutional neural network mostly consists of three layers. One is convolution, one is max pooling, and one is ReLU. We'll come to each of that in a short while. So convolution layers basically search for patterns. Okay. For example, say this is the number 0. If it is hand drawn or something like this, the image of the number 0. So what does this image consist of? It consists of these arrangement of pixels. For example, this 45-degree diagonal, this 135-degree diagonal, again these two diagonals, right? And two vertical strands and two horizontal strands. Okay. So what convolution layers do is basically look for these kind of patterns, these stuff like that. So again, I will quickly open Paint. So let's say this is an image. It consists of this number 0. This. Or say I'm using this one. Say I'm using this one and this, say 0. So this is my 0, right? So what will happen is the convolution layer basically is like color. The convolution layer is basically something like this. This is a filter. What it will do is it will move through the image. So as it is moving through, it is encountering these pixels, right? This one, as it moved further to the right. And again, this part, again, it further moved to the right. Okay. Then again, it will go back, go a step below, and again start scanning. Okay. So basically these layers keep scanning the image, and while doing so, it is looking for certain patterns in the image. So this is basically the idea of a convolution. It's actually moving through the image, performing convolution operation. In signal processing, we do this convolution operation. And by doing this convolution, it generates a value. And that value is again passed on to the further layers in the right? This is how a convolution layer works. Okay. So these are the patterns it is looking for. And while doing so, it is doing certain type of pattern matching. For example, this particular image refers to 1, right? It will not refer to 0. Why? So for a convolutional neural network, so for both 0 and 1, you have these vertical strands. But 0 also consists of horizontal strands and diagonal strands, which are not present in 1. So in that way, it will be able to discriminate. Okay, when I see 0, these values are generated. When I see 1, these values are not generated. So, okay, there is a pattern there. This might not be 0. This might be 1, something like that. So after convolution, we come across something called max pooling. Why are we doing max pooling? Because there are never always one convolution filter. There will be multiple convolution filters. And those filters will try to get very good features or different types of features from the same image. And overall, the thing which we obtain after convolution on an image will be really large in size. So we should definitely, since we cannot process larger and larger matrices as we go deeper, so we should be able to downsample somehow. So what we are trying to do is we are trying to reduce information without losing important information, in a sense that, see, from 1034, I will choose the maximum value. Then I will move right by step 2, come here. The maximum value is 8. And again go down, look at here, maximum value is 5. Again go below, look here, maximum value is 6. The idea is, see, these values in an actual image, these values will be pretty close to each other. So even if we are downsampling, we are not losing a lot of information, right? Since the values are pretty close enough, this will act as a good representative for all of them, right? Same for all the other sections of the matrix. So we do max pooling. Then we do something called ReLU. So what is ReLU? Once we are done max pooling, we should. So ReLU is a function which basically converts negative to 0 and preserves the positive values. So 0 remains 0, minus 1, all the negative values become 0. All the positives remain as they are. So why are we using ReLU? So there are two reasons. The first reason is that ReLU is a way to introduce non-linearity into our model. So what we are trying to learn is the relationship between the image and the class, right? We are trying to learn the relationship between the image of a bell pepper to the label bell pepper, or the image of an elephant to the label elephant. Now this relationship, we don't know what the relationship is, right? It can be extremely non-linear. So if we don't use ReLU, if we don't introduce non-linearity into the system, the overall model will always be a linear model. Okay, it will never be able to identify non-linear relationships within the model, which is why we introduced ReLU. There are other such functions as well. ReLU has another advantage, which is that when we are training, so we use this technique called back propagation. Okay, so what is back propagation? Okay, again I will just the closest thing to a blackboard, I guess. So let's say this is one layer, this is another layer, this is another layer, and so on, right? And here is your final layer. So what usually happens is, can we rotate this? Okay, there is a, yeah. Sorry. Yeah. So what happens is when you are training the network, all the information that you obtain here is propagated to the left. So the layer which is close to the output gets updated first, then the information passes on towards the left. Now, as it passes on towards the left, we are basically multiplying fractions. Okay. So information is stored in form of fractions or in form of derivatives. Now these derivatives, when they multiply with each other, since they are fractions, they get lower in value. As a result, the update for these parameters is extremely small, and they don't end up learning a lot. So we want all the layers to learn important patterns or trends within the data, which is why when we use ReLU, the derivative does not go less than 1. So in a sense, the information is preserved to some extent. Is this part clear why we are using ReLU? Why should we introduce nonlinearity and why ReLU is useful? Yes or no in the chat? Any questions?
Any questions from the participants here?
Yeah, if you're comfortable with it, I think we can see. So we have fully connected layer, softmax layer and classification layer at the end. So fully connected layers are, so convolution layers are not fully connected. There are certain connections which are not there. Fully connected, all the connections are there. There's a softmax layer which converts vectors into probabilities. And finally, there's a classification layer which will categorize the image. And which layer should I use? So for feature extraction, we will use convolution. For activation function, ReLU. Sometimes 10H is also used. For sequence data, you have sequential networks like LSTM, bi-LSTMs. For normalization, you have batch normalization layer dropouts. And you can refer to certain research papers, which will give more, like sometimes the ideas also depend on the kind of data set that we have. So in research papers, they will mention the data set, also the corresponding approach. So you will be able to understand under which condition, which layers to use. So we need three components. First of all, we need data. But for deep learning, we need quite a lot of data, which is not a problem these days because cost of sensors have gone down. And there are quite a few properly curated data sets also available for public research. Good network architecture and good training options. Okay. So we will quickly jump onto the example. We will actually build a network from scratch where we will apply all these concepts, all these ReLU and convolution and all of that. So let's go back. Let's see this one. Okay. So first of all, we have a data set called MNIST. So in MNIST, what do we do? The MNIST data set basically consists of single digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and their images. Okay. They are 28 plus 28 images. We have that data set. We will divide it into training and testing parts. So we will train the model with certain parts and test using certain parts. And we will see how the predictions are working. And also we will try to visualize the activation system. So first step is, first of all, this dataset is already available with the MATLAB installation. So when you go to the file location, all you have to do is get the files and arrange it in a particular data format, which is called image data store. I'll explain what image data store is all about. Let me run this cell first. This part is run. So if I go to, okay, let me just clear up a few things first. Okay. Again, run it. Okay, so image data store is with us. So what is this image data store look like? If we double click on this one, see you have all the information for the data set. What are the name of the files, on which folder it is kept, what are the labels, what is the read function, different things. So if I go to files, so this basically contains the location of all the files. Okay, all the files. And it is kept in a single structure known as image data store. And it is really easy to process data when it is kept in an image data store in MATLAB. So we have the image data store with us. Now, how many files do we have? We have around 10,000 files. Okay. So what we are trying to do here is first for training, let's keep maybe 75%, and for testing, let's keep 25%. Okay. So for each class, how many classes are there? 10 classes. So for class 0, number of images for the class 0 is 750. Number of images for the class 1 is 750, and so on till 9. So number of images of class 9 is 750. So 10 classes, 10 into 750 is 7,500. So out of 10,000, 7,500 are training images, 2,500 are testing images. And we can split that using this command, split each level and number of training files for each class. And we'll just randomly do that. Okay. Just to avoid any kind of bias. So now we are creating, let me just, there are two image data stores, image data store train, IMDS, image data store train, and image data store test. So now we have the data with us. If you remember, the first part was data. The second part was to decide the architecture of the model. Now we can do that in a pretty easily using a certain app called Deep Network Designer. Okay. So go to apps. Under apps, you will find under machine learning and deep learning. By the way, if let's say you are using these apps pretty frequently, so you can avoid scrolling down every time. All you have to do is click on this button. It will just move the category to up. So it moves up. So Deep Network Designer. Might take some time to open. So Deep Network Designer is here, and we will build a neural network from scratch. Just start it. Okay, let me open it again. Yeah, so here it is. This is the initial interface. Okay, for Deep Network Designer start page. In the first page, you can click like create a blank network, or you can use existing networks. There are quite a few existing networks. For example, SpeechNet, GoogleNet, ResNet 50, Efficient NetB0, and others.
Pratyush?
Yeah.
Yeah, sorry to interrupt.
Sure.
I think so it is still loading for a few people. So
Oh, okay,
can
okay.
we
Yeah, we can
take
wait.
for 2 minutes? Yeah.
Yeah.
Can we have a count for those who it's not opening? Still needs to open. Open. Okay. Okay, you are left out. From the online people.
Yeah, those who are, you can respond in the chat if this part you are able to open the
Yeah, in the
start page.
online, if you cannot able to open it, please respond in the chat box.
If you are able to open it, type yes so that we can get to know that you are successful. I think one mentioned, Yogesh mentioned. Thanks for letting us know. As I mentioned, yeah. I think those who are in the chat, they are able to.
Okay. I think so. Here, 2 to 3 are left out. You minimize it. Can you minimize it?
Yeah, that thing will rotate. All you have to do is minimize it and then this.
Yeah, I think so. Now we are good to go.
Okay, awesome. Great. So there are different existing feature networks that are already there, but we will try to build something from scratch. So please click on this blank network, which is new. So you will end up with this canvas. Okay, and in this canvas, you have 3 tabs: designer, data, and training. We will design it here. We will load the data here. We will train it here. Okay. So since we are dealing with an image, we are feeding image as input. So the first layer for the network should be an image input layer. Okay. So what I have to do is, if it's already there here, so all I need to do is drag and drop it. Okay. Or if you are not able to find it here, you can search image and then drag and drop it, or right click on it, maybe. Yeah, I think dragging and dropping would be the best. Now, once you have dragged and dropped a particular layer, at the right, you can see different properties of the layer, right? Say the name of the layer, input size, and so on. Now, the MNIST images are not that large. They are of, first of all, they are grayscale images. Secondly, they are of shape 28,28. So input size I can change here only. So let's not keep 1, let's keep 28. Like even if you just write 28, that will also do. It will automatically assume that it's a square size, but okay, 28. Okay, so this is the image input. Next, we need to add a convolutional layer. So if I press Control and scroll back, things will get smaller, right? If I press left Control, scroll forward, things will get bigger. I'm slightly making it smaller because more layers will come up. I'll get some space. So Control. Okay. And forward and backward scroll. So next I need a convolution 2D layer. It's already there in this canvas. I can just drag and drop it here. Now I can change the properties of this. First of all, 3x3 is fine. Number of filters, initially I might not require a lot, so I can take 8. What else do I need? I need to normalize the data, because normalizing the data ensures that your network converges faster. So by converges faster, I mean it trains in a fast, like gives you good accuracy by training faster. So we need a batch norm layer. Just search here, batch normalization. drag and drop. Okay. Batch norm is done. What else do I need? If you remember, we need a ReLU also. So ReLU, there are different versions of ReLU. These are under activations. I will just take the normal ReLU and connect. Then what layer is left? All this convolution and everything. See, we are using 8 filters. So this will generate an 8-dimensional matrix or something like that, right? So there's a lot of data that has been generated. So we need to downsample it. So we need a max pool layer. So for max pool, max pooling to the layer. Pool size 5,5. Let's make it 3,3. Because the image size is not that large, right? So maybe we can have smaller filters in this case. Now, what we can do is like we can repeat parts of this network by copying it. For example, say this conv will like this part conv, then batch norm, then ReLU, then max pool. This will be repeatedly used as we go deeper. So what we can do is like we can copy this. And after copying this, just use our cursor keys, the down arrow, to bring it down. Okay. This is fine. And we can simply connect this. Now, the only change I will make here is instead, earlier we used 18. Now we have gone slightly deeper. So we can increase the number of filters. From 8, let's make it 60. Are everybody able to follow along till this step? I'll just give some time, maybe a minute. Just let me know once you are able to do that by typing yes in the chat. Anybody facing any issues, feel free to let me know. So just to recap, we took an image input layer, convolution, batch norm, ReLU, max pool, and we sort of copied this part and pasted it here, just changed this particular number of filters. Can you type yes in the chat if you are able to do till this step?
Anyone is facing any issue here?
I could see one yes in the chat. Thanks for letting us know. Others, if you are able to do so, feel free to let us know. Yeah, I can see another.
I think so people from here can able to do it.
Okay, awesome. Thanks for
Anyone stuck anywhere? Okay, 1 second.
Great. Thanks for letting us know. So I will again repeat the same thing.
Is it coming? Pratyush, just a second.
Sure.
So when copying from one batch of set to another one.
Yeah.
So how to connect both the batches?
Yeah. So I'll just again do it. So let me just delete this part. So okay. First of all, let me select this I've selected it. I have just copied it, Control C. I have pasted it. So it's right atop the existing one, right? So now
Yes.
I am using the downward key on my keyboard to keep it slightly down. And just below the purple one, because we are just stacking layers one below the other, right? So
Yes.
now here, just if you zoom slightly into it, just take this dot, drag it and drop it, and it's done. Make sense now?
Is
Just
it
click on this dot and connect it.
dot?
Is this part clear now?
Mhm.
Awesome.
So I think so you need to connect to the convolution one because this is an input, I think.
Yeah. So what happens is the output of the max pool, right, always gets connected to another conf. Then again this process repeats, and this is how we create a deep network.
Because
This is one way to make it.
yeah, I think so we got it because
Yeah.
they were copying both the inputs also.
Yeah. So the input layer will only be there at the initial level. Then we don't need any more inputs. Then all the inputs to the conf will be coming from the max pool layer itself. Okay. So again, some change instead of 16. So if you remember the trend, last it was 8, first it was 8, then 16, now it will be 32. Sorry. Yeah. Done. So at the end, we can avoid a max pool because this is the end of this feature extraction part. See, this part from the input to these where we are using convolution, max pool or ReLU or this. This is the part which extracts good features out of the image. So at the onset of today's second part of the session, we said that deep learning is about automatic feature extraction. So this part is the feature extraction part of the network. The part which will follow now will be the classification part of the network. So for classification part, we don't need a max pool 2D layer, we can just remove it. Instead, what we can do is we can have a fully connected layer. And just connect it. See, output size is 10, which totally makes sense because for our case, we have 10 classes, right? So for 10 classes, we need the output size to be 10. So this is what we want. Input size is automatically decided when we feed the input to this layer. So we don't have to specify that. It is auto. Now, what else do we need? We need a softmax layer. What will the softmax layer do? It will convert the output of this fully connected layer to a probability vector. Okay. And the index with the highest probability value will refer to the predicted class because that has the highest probability. So it is highly probable that this data belongs to that class. So in that sense. So we have to convert the data to a probability vector. So for that, we need a softmax. See, the images of the layers are also indicative, right? Because if you notice, if I zoom in, see, when I was explaining convolution, I took the help of that paint, right? I showed that, okay, this is a filter, it slides and then moves down and then slides and so. ReLU, this is the ReLU function. Fully connected, all the neurons, input neurons are connected to output neurons. Softmax, this is like a histogram, right? A histogram refers to a problem. So in this way, the images are also indicative of the function or the task that this particular layer is performing. Finally, finally we need a classification layer because we are doing a classification task. If you are doing some kind of regression task using deep learning, instead of classification, you could have used regression layer. But currently we are using classification layer. So I'll slightly zoom in and connect. And that helps us to design the network. So if you look at this, there are 15 layers and there are 13 connections. So we are done with designing the architecture. One more thing which I wanted to mention was in deep learning, say, scroll down slightly. In deep learning, especially in case of transfer learning, where you are using certain pre-trained network to do certain classification, you might want to not update certain layers. You might want to freeze. Freeze in the sense not update the parameters of certain layers because they are good parameters. You might not want to lose them. So in those cases, in case you want to freeze a few of them, make this weight learn rate factor and bias learn rate factor for those layers as 0. Okay. This means with respect to the global learning rate, the learning rate for the weights for this particular layer is 0, which means this layer's weights are not getting updated. This layer's biases are not getting updated. So in case you want to freeze certain layers, you don't want to update them, which is often done in case of transfer learning. This is the way to go. Okay. Just wanted to share that. So we have already designed it. Now we want to load the data. So go to import data. Click on this drop down, import data store from workspace. Okay. So train data should be my training data, IMDS train data store. Validation is something on which we check how our accuracy is increasing before exposing the network to the testing data. So it's like a sanity check. So before you test out your results, you will just separate out a chunk of data and run a test, a sort of a small test on it, just to check whether your accuracy is increasing or not. And based on that, you can change certain parameters of your model. Okay. So we have not separated our validation data as such. We are just using the train data as validation. And so it will just show you how the data looks like. For example, say for 0, this is 0. This is 0. Right? This is 0. This is also 0. And so on. It has 1s and 2s and everything. It's just showing you the first 5 observations. So we have the data with us. We have the designer with us. We can train the model. So let's go to train. Now, you can choose different training options by clicking at here. Okay. For example, say initial learning rate is 0.01. You can change it to 0.001. Or maybe, what is the solver? You want HDDM or ADAM? There are different types of solvers. What kind of, so there are different kinds of parameters. Okay. And you can train with different parameters and try to check what your validation accuracy is. If your validation accuracy is not improving, then you might have to change some of these parameters, try again and see if it again increases. So in this way, you can do some trial and error before reaching the most optimal set of parameters. These are rather hyper parameters because we don't learn them. We rather we can change them on our own. So let's not change any training options for now. Let's keep it the way it is. SGDM Adam RMS plot. Let's keep it as SGDM. Now, if we click on train, a window will open up and we will see how the training works. It will take some time and the training will start. See, the training has started.
Loading is going on. Data loading is going on.
Yeah. So if you notice now, the training is going on, right? And within a very small number of epochs, it has gone up fairly high, right? And if you notice the loss also, the loss value has also gone up to almost 0. Okay. And it is happening really fast because we are using a GPU. If you are using
Pratyush,
yeah.
yeah, sorry. I think so they are getting some error.
Okay, what sort of error are they getting? Can you please?
I think so when they are defining the network, some error is training with train network failed, invalid network. So I think so when they are defining this convolution 1D layer, input data must have one spatial dimension. Does anyone has facing the same error? Okay, one more person is facing the error. Maybe while defining the network, the number of filters or something.
Just make sure that the input sizes are consistent, right? So the input size is 28,28. Is change that. By default, it has some other value. So change the image input layer. So I'm just showing you what changes I have made. So in the image input layer, 28,28. In the convolution layer, 3,38, the first one. In the second one, 3,316. In the third one, 3,330.
In the first convolution layer, it is 338.
Yeah, 3,3. Yeah, 3,3 and
3,3 and 8.
Yeah.
So I think so. It was the filter size. I think the problem was because they are using the higher filter size and then but still it should not unable to set filter size.
So then you have to again train. Just click on train. It will again.
3,3.
3,38.
So can you just give it? Stride is 1,1. When we are giving 3,3, so it is we are having some errors unable to set stride. Okay, filter properly, no?
Yeah, I'll show how to import data, Yogesh. Yeah, good question.
It mentions that filter and stride should be scalar.
Stride should be, so I did not change the stride. It was 1, 1. It was exactly what was there initially.
Okay. Yeah. This is fine, right? Okay, there is a mistake. So they have imported conversion 1D layer. So that's why maybe.
Yeah, since we are dealing with images, we have to use convolution 2D layer. In case you are dealing with audio signals, in those cases you can use convolution 1D.
2D layer.
Here,
yeah, I think so. The convolutional layer is the problem, I think.
Yeah.
And can you able to load the data?
Yeah. So I guess some people also had questions around loading data. So if you go to data, click on this drop down, import data. import data store, then just choose training data as IMDS train, validation data again as IMDS train. We don't have validation data as such. We are just using training data to validate.
I think so. It is. Is it the same case? Fine. Yeah. I think so. That's fine.
Right?
Just a second.
Sure.
Hello, sir.
Yeah, please go ahead.
I think I selected first one in import data, so that's why I'm facing issue.
Oh, okay. So
yeah, image data.
Yeah. Since we already have the data as data store, it's really easy if you go ahead with the second.
Okay.
Is there anyone else facing any issues?
Sir, then how to stop that loading?
Okay, so sometimes, good question. Sometimes you will the number of epochs will be fairly high, especially if you are using CPU, it will take a lot of time. I'll just show you quickly. So I'm again training, just discarding the results because it won't take a lot of time. Yeah, so I'll show you. See, when the training is going on, you have the stop option, right? So let it increase to around close to 100%. I'll just stop that up. So if it goes to close to 600, I will probably stop. Because now it has kind of converged, right? So I'll stop. It will take some time to stop. But see, validation accuracy is 99.65%, fairly high. And in this way, there will be a stop option. If you click on it, it will stop midway and just hold on to the last updated parameter values.
Can we set the iteration limits like?
Yes, we can. So training options. Maximum epochs. This you can change accordingly. So instead of 30, you can make it 20. Basically, this part takes care of everything.
And one more thing, Pratish, while doing this import data store,
Yeah.
so one of them is facing the issue that there is a empty data store, like it is not available.
So there are two options: import image data, import data store. Since we have a lot of images, it's better to go with data store. So I'm clicking on the second option.
Yeah, so this is you are getting IMDS image data store, right?
Yeah, exactly. So don't select that. Go with IMDS train because we are going to train on the training part.
Okay.
Similarly,
Okay.
validation also train. I mean, we could have separated out validation part, but yeah, we can do it later also. The idea is training should always be done with training.
Yes.
And the testing part should be kept separate. If we import it, it will get imported. Since we already have it imported on our end, I'm not importing it again. So everybody, has most of you reached this part? You can let us know in the chat. Those who are attending in the classroom, they can also let us know. I can see one yes. Any questions before we go ahead with the next steps?
Yeah. Okay, there is an error of result failing to train.
Okay. So this is happening in this tab, right? Training progress.
Yes. So training, you must specify a folder containing data. Okay. You have imported, right?
Yeah, just make sure the data is imported properly. I think if the architecture is correct and the data is correct, Maybe it should not throw error.
So once the data is imported, we have to go to the training tab.
Correct, exactly. And
then train.
Or maybe if you want to experiment with different training options, we can change that as well.
Make sure the data is in the same order. Okay, your architecture is in bit. Wait. In the architecture, this input should only come in the first subsequent like batches. Yeah, because you're giving input only once, right? After that, there should be a subsequent. Just maybe now connect these things. Okay, and in the third layer also. Yeah, I think so. There is some problem in the architecture. Because of that, we're not able to train it.
Right.
Design. Can you just zoom the design part?
Which one?
Yeah. So the common mistake is the first only the input should be given at the first because we are giving input only once. Then later only layers should be there.
Right. The image input should come only once at the onset, and then it will be just combination of convolution, batch norm, ReLU, maxpool.
Yeah. Because we are having many hidden layers, we are just repeating the layers.
Right.
Just a second, Pratyusha. I'm just helping them out in the architecture.
Yeah, sure. Please take it.
Pratyush, can you go down in the output layer?
Yeah, sure.
The last is softmax and then class output. Can you add class output? Are everyone able to successfully define their architecture?
Not getting class.
So where can we get the class output layer?
Okay, so this is basically classification layer. So all you have to do is, one way is to just search classification. And the other way is to maybe go to this output drop down, which is at the bottom, I guess. Yeah, here you will find classification. So just drag and drop it.
This one. You just connect it and then we got it, I think.
Great.
Are anyone facing issues in defining the architecture? Once you define the architecture, load the data and then train it. The convolutional layer should be 2D.
Correct. Conf 2D, batch norm, ReLU, then maxpool. Maxpool 2D, by the way, again.
Yes.
Maxpool 1D is there. It's full maxpool.
Because we are using the 2D image.
Yeah. Just
People in
one
the
more.
online, yeah.
Yeah, please go ahead. Yeah.
People in the online, if you are facing any issues, please let us know.
Yeah, right. You can put it on the chat as well.
Yeah, please mention in the chat box.
Yeah, so one thing just I wanted to mention. So initially when you just tag the layers, right, things might not be aligned properly. For example, it might, slightly tilt to the left or to the right. It will not be arranged properly. So to arrange it in a linear fashion, just click on auto arrange. Okay. This will just make sure everything is really tidy and layers are stacked up properly. There is proper spacing between two layers, stuff like that. So just click on auto arrange. Everything will be stacked up properly. So everyone in the classroom, are they able to follow? Were they able to train and get the network results?
Few of them were able to successfully train their model. Few of them are still trying.
Okay, good. So we'll wait for 2 or 3 more minutes.
Yes, Pratyush. The epochs should be stopped manually, or because I think so here it is written 2340 epochs.
Yeah, sorry, which one?
The training of the epochs.
Okay. So you can change it in a non-direct way by going to training option. So all you have to do is, so max epochs you can change. So it's 30 currently.
Okay.
And you can change the mini batch sizes. So accordingly, the number of iterations will vary.
Yes. Just stop it and change the epochs. Stop, I think. It is stopping. Wait. Once done, you can change the epochs, I think. Then just give 80 to 100 and then try checking it. Are you people able to do? Is there anyone who needs further help for the architecture or in the training? You change the epoch size? Okay. Okay.
So it becomes 16.
Okay. You have defined the architecture? Okay. Pratish, while importing the data, there is an error. Can you show me the error? Import data store. no database, no data store variable in workspace.
So to have the data store in the workspace, what we can do is we can just minimize this. Go here, just make sure this IMDS chain is there in the workspace. Can you check once if they are there?
For those who are facing the error, can you check this?
If they are not, just run this two cells first. So run this first. This will
Let's
ensure
run
that
those cells first.
let's run this.
So import the data here first. We have to import it here first.
Yeah. So all the variables will be accessed from the workspace. So we have to make sure that
Yes.
everything is there in
Okay.
the workspace.
You're able to get it? I think so now 80% of the people can able to get it.
Awesome. In keeping in mind that we might have a few minutes. I'll just quickly maybe move on to the next step. Those who are just training it, just the next step would be, export this model that you have trained to the workspace. For that, click on export on this drop down. So export trained network and results. There are multiple things which you can do actually, but currently this will be the most relevant for us. So the first option, after you have trained, click on export trained network and results after clicking on this drop down. Okay, this one. If you click on it, it will show you exported trained network _1 and trained infostruct _1 to the workspace, which means the network is now available with us. Okay. Now we should switch back to our live script. How to switch back? Click on this button, switch windows, click Network Designer. Again, back to the live script. So now we have the training results. We will just compute the accuracy. We will first get the predictions and check how good our predictions are. So we are taking the network, classifying the test images, IMDS test, obtaining the actual labels. So this is the predictions, these are the actual labels, and we are actually comparing them using something known as a confusion matrix or a confusion chart. Okay. So again, let me just bring it in line. I run this. So let me explain what a confusion chart is. So if I open figure in new window. So these horizontal lines refer to actual classes of data. And these vertical lines refer to predicted classes of data. This is like a matrix where this diagonal refers to true class is 5, predicted class is also 5. This one refers to true class is 5, predicted class is 4. This one refers to true class is 5, predicted class is 1. You get? Were you able to understand, make sense of this particular matrix? Yes, in the chat, if so. Does this matrix make sense? Yeah, I'll repeat. So see, it's a multi-class classification, right? So there is a high chance that you will make mistakes. But what kind of mistake are you making is what matters. For example, if your true class is 9 and predicted class is 9, then the intersection of this row and this column is this one, which means there are 248 instances out of 250 where, I mean, for 248 test data images, you have true data as 9 as well as predicted data as 9, which means the classifications are proper. They're correct classifications. For one of the instances, the true class is 9, but the predicted class is 4. And for one of the classifications, the true class is 9 and the predicted class is 2. Similarly, for this particular row, let's say, for class 4, there are no misclassifications because apart from 250, no numbers in these cells, right? Which means there are no misclassifications. Here, for 2, true class is 2. So for 250 images having true class equal to 2, there are 248 which are properly classified. There are 2 which are misclassified as 1. So this is how we compare how the misclassifications are occurring, which class is getting misclassified into which class. Make sense now? Any
Was
questions?
everybody clear on that?
See, for every class, for every class there are 250 instances. So this diagonal element represents 250 of actually 250 data set like images which has a label of 0 are properly classified. But for label 1, 3 are misclassified as 2, 1 is misclassified as 7, 1 is misclassified as 8. Similarly, for true class 2, out of 250, 2 are misclassified as 1. The rest 248 is misclassified as. So in this way, we can see the misclassifications. So the classifications are pretty well, right? Because the worst is 1, but that is 245. That is also 98% accurate. And there are even classes like 0 or 4 or 3, which does not contain any misclassifications. So our network does a fairly good job at predicting the labels for the digit images. Clear to everyone how this confusion matrix works? It might seem slightly confusing, but yeah, just look at the rows. The rows always add up to 250. Any row you take, because that is the actual number of data. The diagonals are correct predictions. Off diagonal terms are incorrect predictions. This is the diagonal correct predictions. Off diagonal terms incorrect predictions. I hope this makes sense.
Yes, Pratish, that was clear, I think.
Yeah, thanks for it. So that once that is done, so let's try to understand why the misclassification is occurring. So if you notice, see 245, let me enlarge it again. So see for 245, something which is 1 is getting misclassified as 2 for 3 instances. And this makes sense because, let me again open Pent. Say, maybe someone is writing 1 as this. Okay, but this 2 is also looking like this. So there are similarities, right, between 1 and 2, which is why if you don't write 2 properly, it will get misclassified. And that is getting reflected here. A lot of 1s are getting misclassified as 2. Similarly, if you notice, a lot of 9s are getting misclassified as, not a lot, actually 1 9 is getting misclassified as 1. Why? Because 9 and 4 have similarities, right? So if I go back to Pent, say this is 9, and say somebody writes 4 as this. So this stroke and this stroke, there are similarities, right? Both of them have these holes kind of, and there are similarities in strokes if not written in the proper way. So these might be the way to explain why these misclassifications are occurring. Now, okay, what about what's really happening inside the neural network. So to understand that, what we can do is we can take the activations, we can take the outputs of the convolution layers from the first one, as well as the second one, as well as the third one. So what we will do is, if I go back to this network, I will take the output from this one, and this one. This is what we are going to do. So what we are trying to do here is, just randomly picking an image containing file index 1800, just randomly taking an image and trying to look at the output when it passes through the convolutional neural network. So the first layer, the second layer, and the third layer. We are visualizing all of them. So if I run it, and open it in a figure window, I don't know if I'll be able to zoom it properly. See, this is the upper one. The numbers actually pretty much look like 7. Okay. But as you go deeper, these numbers are kind of blurred. Does not make sense anymore. Now, why is this happening? Because at the initial levels of the layers, the convolutional neural network looks broadly at the image. It does not look at it pixel wise. So it will look at really low level features like edges we saw at the first part of the session, or like maybe colors if it was a color image. So the initial layers look at very low level features. By low level features, I mean which are kind of generic, which are not that good in discriminating between classes, but they are interpretable, no doubt, which is why the outputs of the initial layers are interpretable. But as we go deeper and deeper, the analysis takes place at a pixel level, which is why now if we want to discriminate between two objects, we cannot just look at its shape because their shape kind of looks similar. Rather, we have to look at the pixel distribution, or we have to zoom in and look at it in a better way, right? So as you go deeper, we try to find out better features which are specific to the dataset. But in the initial layers, we look at features which are kind of generic, like edges or say colors or things like that. So this is how we can make sense of the activations which we are obtaining. Make sense to everyone? If yes, can you please type yes in the chat? Yeah. Everybody in the room, do I make sense?
That was S, I think.
Awesome. Right. So in this particular exercise, we tried to build a neural network from scratch and tried to, train it, predict the labels, generate the confusion matrix, and also try to visualize what's like the internal mechanisms of the CNN. So for more details, if you are really interested to learn deep learning, we have something called deep learning on-ramp. If you have not done it already, I would strongly recommend that you do. So just give me some deep learning on-ramp. This is there. So we don't have a lot of time left today. I will just spend a few minutes answering Q&As from everyone. But just to introduce you to deep learning on-ramp, since you have your MATLAB Mathworks account, you can definitely try these courses out, right? So what you have to do is just go to matlabacademy.mathworks.com Here you will have on-ramp courses from different domains. If you go to AI, machine learning and deep learning, you have let's go to AI, machine learning and deep learning. Here you will have deep learning on-ramp. Right? Here from intro to everything has been covered. So on-ramp is just an introductory course, but if you want to dig deeper, go to home. Take some time. Deep learning with MATLAB is slightly more advanced than deep learning on ramp. It's also 8 hours, so more exercises. So you can go here, and there is a lot that you can do. So creating networks, not only for computer vision, but for sequential data, for time series data as well. For example, if you have stock price data or some kind of audio data, how do you classify that? So all of that will be covered in deep learning with MATLAB. So feel free to complete these on-ramp courses at your own pace. These are self-paced courses. Yeah, I think this kind of brings me to the end of my part. But if anybody has any questions, I'm there for a few minutes. Feel free to go ahead. You can unmute yourself, post it in the chat. Anything will work.
Yeah, if anyone wants to interact with Pratyush on deep learning or MATLAB, please feel free to do that. He'll be available for the question and answer session. Anyone from online, so you can unmute yourself and interact with him.
Yes, yeah, feel free to go ahead. Can we do reinforcement learning on MATLAB? Good question, Rohan. Yes, of course we can. So if you want to get started, I just quickly share my screen again. So we have this on-ramp called reinforcement learning on-ramp. 3 hours session, 5 modules. So the way this on-ramp is designed is like you will be given a problem, real life problem, and you will break down that problem into different parts and you'll be solving it while learning about reinforcement learning. So feel free to take this on-ramp first. And we have documentation around reinforcement learning as well. So for example, if I search MATLAB documentation. There is another question, just taking a look at it. Signal processing using deep learning. Yes, it can be done. So anything, if you have any doubt around any topic, feel free to refer to the doc page. First, let me address the question on reinforcement learning. So yes, we can of course do that. Reinforcement learning toolbox. Just click on get started and you will get to see a lot of examples where you can train reinforcement learning agent for different problems, right? Mostly robotics. So that will be done. There was another question. Let me look at it. Can we store the data in a memory device where we can program on MATLAB? Can we store the data in a memory device which we can program on MATLAB itself and use that for image processing using ML? So we can, like, by data, do you mean image, Saurabh? The image data?
Like we are working on memory register, so we have made its a model.
Yeah.
And in that, using that model, we are trying to do image processing, and my senior has done
But
Yeah.
since I'm not from that computer background, so unable to understand that. So that's why asking the same.
Yeah, we can definitely store the data in a by a memory device. So which data are you referring to, like the network or the data set itself?
Image data set.
Oh, right. So yeah, it can be definitely stored. So for example, in this case, we used an image data store. What we have to do is, so if I go here, you have the data stored in a folders. So let's say someone has already stored the data in, yeah. You are not too audible, sir. Can you repeat once more? I think I'm losing you. Are others facing the same issue as well, or is it just?
Hello?
Yeah,
Pratham?
yeah, I think.
Yeah.
Yeah.
Okay. So last question was from Saurav, right?
Right. So just to answer, if we have the data with us, if it's arranged in a folder in our computer, all we have to do is use this image data store command and the path to the folder. Then MATLAB will automatically convert it to an image data store and continue working with it. So even if the folder is present, no issues. We can easily convert it to an image data store. For example, here we used an image data store because it's really convenient, but just this command will do. Image data store, then path to the folder. Signal processing using deep learning, good question. Yes, it can be done. So yes, signal processing using deep learning. I'll just search for. There are wave applications around wavelets, I know. So deep learning for signal processing, if you go. So all the steps from labeling signals to transforming data into time frequency domains to good feature extractions. There is actually a feature extraction, like a toolbox, which will help you to do that. And once that is done, then designing the network and everything. So from labeling data to designing the network and finally deploying it, everything can be done. I hope that answers Yogesh's question. Yeah. Great. Any more questions?
Sir, I have a doubt.
Sure, please.
Sir, when we open an image here,
Yeah.
color image,
Correct.
we are seeing only a single matrix. Shouldn't it be like 3 matrices?
Oh, okay. So by default, so the problem is like since there are 3 matrices, just hovering over it will only show one, probably the first channel, which is the red channel. But if you want to, read multiple channels, so let me just go to the IPCV one again and open up one of the examples. So let's say ML01 image, this one. So I am read. Let me just again read the color image. So I think you are saying that if I hover over it, I'm just seeing only one. But the problem is that there are 3 channels, which is why if you want to look at the entire thing, you can go to the workspace. And here, if you click here, you can go to 2, like just increase it to 2.
it will show 2. You can increase it to 3. Okay, accordingly you can see. So
Yes,
on just a single glimpse, not the entire image might not be visible, but if you go to the workspace, everything will. Okay, question, can you explain confusion matrix? Yes. So there is a reason why it's called confusion matrix. Let me go back. It definitely creates a lot of confusion. So the idea is there are multiple classes and every class might get predicted to so this is just a substitute of the like a blackboard. For example, say I have 0, I have 1, I have 2, I have 3. And here also I have 0, 1, 2. Now, as far as predictions are concerned, 0 can, this is true class, this is predicted. So 0 can get predicted as 0. Another instance of 0 can get predicted as 1. Another instance can get predicted as 2. One of them can get predicted as 3. Similarly, for 1, it can get misclassified as 0. It can get properly classified as 1. It can get misclassified and so on, right? So the idea is, along a particular row, you have all the instances of test data for a particular class. These are actual data. These 250 instances are the actual 250 zeros whose actual labels are 0. But that does not mean that the image will correspondingly give a label of 0 because the network can make mistakes, right? So for the test data, we have an actual label and we have a predicted label. The predicted label might match with the actual label, might not match with the actual label. If it is not getting matched with the actual label, then it is making mistakes, right? So this particular row, the uppermost row, refers to all the points, all the data, all the images whose actual label is 0. This column refers to those whose predicted label is also 0. So if you notice, out of 250, all the 250 are predicted as 0. It could not have been the case. I mean, this could have been 240, this could have been 5, this could have been 5. This means total 10 misclassifications, 5 as some digit, say 4, and 5 as some other digit, say 7. Similarly, for say 1, it will be 245 correct classifications, but 5 misclassifications. Out of 250, 245 proper classifications, 5 misclassifications, out of which 3 has been misclassified as 2, 1 has been misclassified as 7, and 1 has been misclassified as 8. So to capture which one is getting misclassified into which class, we need this kind of a matrix. And this is called a confusion matrix. Make sense now? Any confusion? Yeah.
Yeah, I think so. That's clear.
Awesome.
Anyone else having any other questions from the chat box? I hope no. So I think so we can conclude here.
Yeah, sure. I think I think we can conclude at this point. So I hope everyone who attended today's session in the classroom found it helpful. Thanks a lot for joining today's session. I think we really got good participation and really good set of questions from everyone, be it in the classroom or be it in the on the WebEx chat. So thanks everyone, and thanks to the IEEE student branch at IIT Indore for organizing this. I think this was really a good collaboration. Yeah, thanks a lot.
Yeah, thanks, Pratyush Rai. So your session was very interactive and engaging also. Deep learning is a very vast topic, and then you still managed to keep it very simple and clear, so which is very much required for the beginners. So thanks for the patience and the response you have been showing to us since the start of this conversation when we started, like we'll organize this workshop. And we would like to thank you on behalf of IEEE Student Branch IITI Indore. So before ending with the thanks note to the participants, I would like to introduce the organizers of this workshop and the IEEE Execom members. So I am Hema Priya, the IEEE chair. So there's one standing here is Harsha, IEEE vice chair, and there is Sainath, who is just yeah, and so he is the treasurer of our IEEE, and there is one more student, Arun Janagal. So she's due to unfortunate circumstances, she's not here, but she helped us a lot with the content and these things. So I would like to thank every one of us for being here. And before ending with the thanks note, I would request all the participants in the online to be like to switch on your video so that we will take a small snap of it, of the participants, if possible. Thanks, Parul, for joining. Yeah, I think so. We are very happy to see very enthusiastic participants. So, Sanat, can you take a snap of it? Okay. Thank you. Thanks, participants, for showing much interest in this MATLAB workshop. I hope you learned the basics of the MATLAB and how to use it in the case of image processing and the deep learning. So, MATLAB has a well-defined simple toolbox where everyone can use it, even though they are not well versed in the coding. So, it is very easy to use. So, I hope it will be benefit to your future works and the research. So, thanks for joining us. Thank you, Pratyush Raj. Yeah, so I'm ending the session here. To the online participants, please collect your certificates once you are out of the quarantine. From either me or Harsha, we will let you know the venue and the time to collect your to collect your certificates. Yeah, thanks. Thanks, Pratyush Rai.
Yeah, thanks everyone for organizing this.
Yeah.
Just